So, good morning. Thank you for waking up. I'm Hendrik. I'm from Belgium. I've been playing with computers for a long time. After I did a PhD, I founded Sigassi, which is a software company in the semiconductor industry. And since about half a year, I devoted my full attention to crypto and started freelancing at Avado. So what's on the menu today? I'm going to talk about home staking with Avado and Rocket Pool. So both of these projects make home staking a lot easier, and the two together is even more awesome, and that's what you will learn today. So maybe back to basics. This is the first talk today. Why do we want home staking? As Supervis once summarized it, solo staking on Ethereum beacon chain from your own home is the most robust way to earn rewards and secure the network. So both you and the network wins, so win-win situation, always nice. But when you start home staking, there's a whole lot of challenges that an end user faces, like what hardware should I choose? What operating system does work? What software package do I need? Which version? How will I update? And what if an update happens when I'm on holiday? Where will I get enough funds? What about security? Do I know enough about it? Also, do I simply dare to stake 32 ETH when everybody's talking about slashing? So there's some emotional stress there too. Also backups, how will I deal with that? So that's very overwhelming, especially for less technical people. It's nice to think I want home staking, but then actually doing it might be more challenging. And that's where Avado and Rocket Pool makes this process easier. So maybe first about Avado. So Avado is a company that sells specialized servers for home staking. So you see it's a very nice designed small computer that's just plug and play. You put in the power plug, you put in the Ethernet cable, and you're ready to go. It's a fanless design, so even people living in small apartments can just hook it up somewhere in a corner and are not disturbed by noisy fans. It also has a very easy UI, so you just connect to it with a browser, so no need to connect keyboards or screens, and then it's simply point and click, and you have a staking device at home. It's secure, and also the Avado team take care of the updates, so you can even enable auto updates, and then everything is automatically. There's also a Dapp store with more than just staking applications, which you can also extend yourself, but that's way too advanced for this presentation. And so the objective is to optimize everything for the staker's convenience. So make everything as simple as possible. So we often have to make the balance between, do we add an extra option or make it simple? Then we try to choose the simple option always. So when you open the UI, we talk about staking today. So you just select two packages, click install, wait for the software to sync up with the chain, and you're ready to go. But staking is also more than just hardware and software. Avado also has a very welcoming community. So when you start considering staking, it can be very helpful to have peers that went through the same process and just encourage and help you with some emotional or just other support. And the values are also allowed with the spirit of the Ethereum values, so we try to be helpful. It's open source, it's permissionless, decentralized, and we also try to support client diversity. Then Rocket Pool. So you can have all the software, all the hardware, but 32 ETH is more expensive today than it was 1.5 years ago. So there it's awesome that the Rocket Pool team came up with a way that you can also stake with less than 32 ETH. We're talking about staking, so we want to run your own node, and a nice thing with Rocket Pool is that you get higher rewards. So you get the rewards from your own stake, then you also get a commission from the stake from the Rocket pool, and then you also have RPL rewards. It's also worth mentioning that you do take some extra risk too, because any penalties because of your offline or anything, that's also paid from your stake. But overall, more efficient staking, so that's a good motivator for home staking. A quick overview of Rocket Pool. So there's a node operator, so that's supposed to be you if you choose to become staking. And you need to set up a computer, a node, which more or less corresponds with a computer with the necessary software. And then on that computer, you can set up one or more Minipools, which corresponds to more or less to a big chain validator. So how does it work? So you have to deposit some RPL, so that's the Rocket Pool utility token as collateral. So if you do anything wrong, you can be punished. And then you also stake 16 ETH from your own wallet, and then the Rocket Pool smart contracts deposit an extra 16 ETH from non-node stakers into the smart contract that corresponds to your Minipool, and then that's deposited to the ETH contract, and so that way your Minipool can start staking and you can set it and forget it. So Rocket Pool did an amazing effort to develop all these smart contracts, and they also have a very great documentation, but is it easy enough? Because most of the choices or the challenges I mentioned at the beginning of the talk, home stakers still have to make. So they still have to pick hardware, they still have to choose on software, updates. So all of these challenges are still there, but that's where the Avado magic comes in. So at Avado, there is already execution clients, there's beacon chain clients, there's validators you can choose. Avado has the automatic update mechanism. And as I will show you next, we also added a very simple UI wizard on top of it, so that it's even for the very non-technical people, it becomes possible to stake at home. So when you connect to your Avado through the web browser and you install the Rocket Pool application, you're presented with this welcome page. So if you didn't install the Ethereum node or the beacon chain client yet, it will present you with these buttons so that you can do that in a few clicks. And then you can, also worth mentioning, so today there's already 2 beacon chain clients in the Dapp store, so that's Teku and Prism, and Nimbus is going to be there very soon. We also guide you through the process of configuring Rocket Pool. So this is already step 2, so I already initialized my wallet. So now I have to deposit funds, which is easy. We also present you with a status of the network. So green is good. If it's not 100% up to sync yet, it will be orange, I think, as a warning color. It also shows you the current gas fee, the commission, although that's fixed now, so maybe we should just remove it. and also the RPL price. So in this example, I did already fund some ETH17 to the hot wallet. So it's always inside here, so easy to follow, and it's green, so it means that you have enough. So in this step, we only have to deposit the necessary RPL to get to the next step in the wizard. We also have added some convenience methods, like just copying the address of the hot wallet to the clipboard, so you can use it in MetaMask. All these things are really optimized to make it as easy as possible. So we'll probably need a few more iterations, but we're already very far. So this is another example of a step in the wizard. So this is where you create a mini pool. So first you have to approve spending RPL with the contracts. Next step is staking RPL, and if there's any feedback from the Rocket Pool smart node software, it's also shown enough. So I cannot proceed yet because I have to deposit or to stake RPL first before I can go to the next step. This is a bit further, so also backups are very important, of course, and there's also an option to add more than one mini pool. Just you can add as many as you have, as you want, as you have funds probably. So that's also all very easy to do. Then there's also a status page that just shows you everything about your wallet and the mini pools. So in this case, the mini pool is created, but it's still in the pre-launch phase. So it's waiting for the beacon chain to pick it up, I think, in this situation. And then once the mini pool is active, so it will start making attestations. There's also convenient hyperlinks. So for example, you can click on the hot wallet, see everything that happened behind the scenes with the smart contracts if you want to know all the details. Also, there's for monitoring, it's very easy to just use the beacon chain website. So it's one click and you see everything that's going on over there. Today, so there's the validator runs in a different package. So we're not using the Docker containers from Rocket Pool, only the smart node software, and the validator runs in the original packages we had for people that do the standard home staking. So here is a similar wizard for the Teku package. So there's a list of validators, so just one in this case, where you also have the hyperlinks to the beacon chain. You configure the settings, and so you just import the key from Rocket Pool, and then so if you open this wizard here, you just add your validator key, and your validator starts validating. So that's all very easy to do with Avado. So the nice thing is, so everything we've shown here, so we didn't touch a command line interface at all. So that's makes it a lot easier for non-technical people. So already conclusions. So I recommend everybody to do home staking. So it improves the Ethereum security, it improves your revenue as well. And because Rocket Pool and Avado make home staking a lot easier, I expect more people to dare to stake at home, and so you can't lose if everybody wins. So that was my talk. Questions?
just a quick one about, you mentioned that you can run multiple validators per one Avado unit. Like, is it, for example, say I'm rich and I have, I don't know, 320 ETH, so I can run 20 on one machine? Like, how does it work? Or system will say, okay, this unit is too cheap, like buy a bigger one?
You can effectively run as many as you want. So you just add in this wizard all the validator keys you have, and Teku can manage it, or Prism or Nimbus. That's not an issue.
I can maybe add some color to that. So in testnet, 4,000 validators were run on one machine with 4 vCPU. Typically in production, people limit it to about 1,000 to kind of keep the blast radius down. But if you have that kind of money, you're probably not running on a DAppNode. So your 10 validators or whatever, they're perfectly fine on there. Other questions?
Can you maybe tell me some more about the automatic updates?
Avado has a Dapp store and just publishes an IPFS index of the latest version. And so if Avado publishes an update, the Avado boxes ping it from time to time. If there is an update, they will download the image from IPFS. So it's all Docker containers. So it downloads a new version, restarts it, and then if you're lucky and then your attestations are in a wider interval, you won't even miss one attestation, or you might miss one, but that's not really, that's just a few cents you lose, but that's it.
How do you handle geth pruning?
We ignore it for the time being, so just make the disk big enough. So you can do it, but then you need to change a command line argument. So it's possible, but it's we postpone the problem for now and wait for the clients to fix it.
It's actually not a bad approach.
Thanks, Hendrik. What if I want to move my validator to a new machine? Is there a migration process for that?
Yeah, but it's a manual one. So you just on one of the other pages of this wizard, there's also just download a backup. Also, if you delete a validator here, you will get the slashing data. So if you have the key, the slashing data, you just move it to another validator. And if you're quick enough, you will also not lose any attestations that way.
So, I have feelings on that, and that is, don't be quick enough. Wait 15 minutes and be safe. Right? Take the couple cents of downtime.
But if you have the slashing data,
if you have the slashing protection database, yes, you should be fine. But still, personally, I'm way more scared of slashing than I am of 15 minutes of downtime.
So this is optimized for home stakers. So you're not supposed to have 1,000 validators. So it's okay to have manual steps for our
Absolutely.
audience.
Okay, maybe one more question. Back there. Okay.
Do you have stock? Can one buy one now?
Stock? Yes. But not with us today. So just go to the website, avado.do, and then you order it. Depending on where you are, it takes a few days, I think, today. Just pick the amount of memory you need, the disk size, and it will get shipped to you. Or ask Jos here, and then he can help you out.
Hand deliver it. I thank you. Awesome. So we have we have a really tight schedule today. So we'll have about a 5-minute break, and at 9:25 we'll have the next speaker. She'll be remote, and then we'll do that in like half-hour intervals. Thank you. So we're gonna do the next thing here. We're gonna have Qingyi Lin from Lumostone. She is developing a Ethereum on Kubernetes project to make it really easy. So if you're not a coder and you hear Kubernetes, you might run screaming out of the room right now. But she aims to make this really simple to deploy, even for solo stakers. So hopefully the Zoom link works. There she is. Hello. Please join me in welcoming Qingyi.
Hello, everyone, and good morning. I know it's a little bit early for you. I hope you all have your coffee and tea. Sorry, there's a little bit of loud here. Let me turn off my speaker for a sec. I can turn it back on when we have a Q&A session. So yeah, I'm dialing from Pacific time zone, so if you feel it's very early for you and are a little bit sleepy, then I'm kind of share the same feeling with you. But I think the excitement trumps everything. Today I'm very honored to present our project, which is Ethereum cross Kubernetes. And hold on, let me quickly get the slide out. All right. So before we kick it off, I want to take this chance to thank Ethereum Foundation for supporting our work as part of the staking community grant. So a little bit about ourselves. My partner, Hu, and I, Qingyi, we have a team focused on some technology around Web3 and blockchain. Our background are software engineer with focuses in Kubernetes, cloud services, microservice development. And this project is our early initiative where we start exploring how the Web2 technology can be used in the Web3 and the blockchain world. So that's how Ethereum 2 meets Kubernetes. And our motivation to start this project is very simple. I believe all the stakers also think about the same thing. It's just that we want to minimize our validators' downtime. However, rumor has it that redundancy will lead to slashing eventually. So let me use an example to further illustrate why redundancy may lead to slashing and where is the problem. So let's say you have two machines and you happen to have 4 validator keys. You will naturally want to distribute the keys onto the 2 machines, like 2 of each, because that way you get to control the blast radius. So if one machine goes down, you can move the keys to another machine and that it continue to run after you wait for 2 epochs. And you take your time, fix your machine, and when you are ready to go back online, you move the key back to the machine and then you turn it on. One thing you may forget is to remove the keys from another node, or sometimes it's just some human error. So you copy the wrong keys and you end up have duplicated keys running on the same validator. And you'll be like, oh my God, I got slashed. And something none of us want. So we can easily see that the operating system becomes much more complex once you start adding more validators, adding more machines. And at the beginning, you are thinking of high availability, but that eventually will just kill your validator. So where is the problem? The error-prone manual process is something always a risk when you need to go on maintenance, when you need to turn down one machine and just run some updates. Although human beings are good at repeating the history, but we cannot quite repeat the exact same steps over and over again. So every time when we need to do update, we feel it's just a very risky thing. So we kind of want to postpone it. We don't want to update it unless we really need to. So sometimes we also write some automation script, but the automation script we wrote could have some bugs or some edge cases that we didn't consider, and that also exposes us to another layer of risk of being slashed. So that makes us think of Kubernetes. It is an open source system that is widely adopted by the software industry. And it is used for automating deployment, scaling, and management for containerized applications. So when we started this project, all the 4 mainstream clients already provide their container images. So they are Lighthouse, Nimbus, Prisms, and Teku. So our project also supports this for clients. So let's quickly check the physical setup. When you have a Kubernetes cluster, you can put 1 or multiple nodes inside here, and you can run your application, which is validator and beacon, on top of the nodes. And Kubernetes will distribute the workloads among the available nodes that you put into the cluster. And on the right-hand side, it is the storage part. So you can split up the stateful and the stateless. All the state, all the validator keys, slashing protection DB, and the beacon node data can be put into a centralized storage pool. And in the Kubernetes world, it is easy to declare the mapping between your application and your storage. So that's zooming to the virtualized world, the left-hand side, the Kubernetes cluster. When you deploy the project, the Helm chart provided by our project, you can see your validator up and running with beacon nodes and a beacon service. So the beacon service, the service part is a Kubernetes resource. It serves like an internal load balancer. So previously, when you have your own validator, you will point them to a list of beacon node address. But with the beacon service, you can get an internal DNS from Kubernetes, and you just need to point your validator to that internal service DNS endpoint. And even you have one beacon replica goes down, this beacon service will check the healthiness of the beacon. If it's not available, it won't route traffic there. So that also simplifies the configuration on the validator side. And that's recap the failure scenario that we just went over together earlier. So let's say now you have 2 nodes, and on each node, each machine, you have 1 validator. Let's say the validator, let's say the green node goes down. Kubernetes will move your validator from the broken nodes to the remaining healthy nodes. And because the mapping between the validator and the storage is straightforward, it's always static, you don't need to worry about moving the keys, moving the slashing DB. The orchestration of moving the validator to another node is also performed by the Kubernetes. So you don't need to wake up in the middle of the night to save your validator. The Kubernetes provides the auto recovery. So that's the benefit of using Kubernetes. And our project, the goal of our project is to give you the tools to easily deploy the validator client into Kubernetes cluster. And also we know the entry barrier is a little bit high if you never played with Kubernetes before, but you still are willing to learn. For this type of user group, we provide a detailed guide, including how to set up the Kubernetes cluster using micro.k.s and how to set up the file system using Linux and network file system. So in the Helm chart, our goal is to provide as minimal as possible configuration for you. So you only need to provide some key configuration and you're good to go. Also, for allow people to explore more, we include auto-generated example manifests from the Helm chart we develop. So these 2 things will always keep up to date. Also, we implement the sort of like doppelganger protection. So before all the clients start having this flag for you to wait for 2 epochs, we also can easily achieve that with extra container deployed along with your validator. It will vet your validator to wait for 2 epochs before it actually comes out and start doing a testation. And well, additionally, there are some extra features that we provide to make the configuration much more easier, such as we will handle the duplicated vol amounts. So the user can just go ahead and just configure the path to your data folder that you want your validator to use. So I put the link here, and later I will share the slide so you can explore on your own. For the demo today, because we don't have much time, I will just go ahead to an environment that already provisioned the Kubernetes cluster with 2 nodes. One is controller, the other is worker. And also I set up a network file system and already put my validator keys inside there for the demo purpose. And just a fun fact, all the nodes, all the incidents are VMs on Hyper-V with a Windows 10 Pro desktop running at home. So if you want to repeat the same setup, I believe you can do it at home. However, in contrast to the talk, the previous talk, they provide many graphic user interface that can facilitate the whole provisioning experience. In our project, we are CLI intensive. You will interact with the command line utility tool. So hopefully the demo can help you to explore the project and just get a feeling of managing a Kubernetes and interacting with Kubernetes, setting up the staking client with Kubernetes. How will that feel like? All right, so let me switch to the demo window. Cool. So I already cloned the project. So in our repository, you will find 4 folders. Each folder represents the home chart for that client. Today, I'm using Lighthouse. So inside the home folder, all the templates are here. You can explore it later on. But for now, that's focused on the values.yaml file. So this is where you will care the most of the time, because that's where you get to configure your validator and beacon setup. So like for me, I'm using Predator as the testnet, using network file system as the persistent volume. I also configure my private network and make the network file system available through this IP for my beacon and for my validator. Some highlights I want to do is around the data directory. So in my NFS server here, I have set up this /data/lighthouse directory. And I will give this path to my beacon, which it will create the beacon folder underneath. For my validator clients, I also put the keys under /data/lighthouse/validator client 1 and client 2, and all the keys are here. So I provide the data directory for them to get the keys. So 2 clients that I configure. And there's another thing I want to highlight here is the permission. When you set up the directory, you need to grant access to particular user and group that your containers will be running. So in my example, I use this 2 ID. These 2 IDs need to match the security context here. This is the section determines what user ID and group ID will be used by the containers you are going to deploy in the Kubernetes. So these 2 things needs to match so the container run in the Kubernetes can access the data folder that you set in your file system. All right, and there's another tip that I will recommend is in addition to modify the original values.yaml, you can also set up a separate file in your local machine and just to override those configuration as you like. So in the example, I'm overwriting the image version tag because I want to demo an upgrade scenario. So I'm set the version to Lighthouse previous release. And also I provide my Ethereum 1 endpoint. I will swap it out the endpoint later on. So no worries, I'm exposing here. I will just close it after this demo. Also, I turn off the wait time. So in the demo, we can see the validator goes up right after I deploy it. And no worries, I already stopped the validator a while ago, so I won't be slashed. So that's switched to the Kubernetes node. So I'm now on the controller node. before we deploy, let's quickly check what components are deployed at the moment. So everything here are Kubernetes component, nothing related to the validator, nothing related to Beacon. With this fresh environment, we can go ahead and deploy our Helm chart that we configure on the left-hand side. So I am in the same directory as the Helm chart. I can use this command that will interact with the Helm, which is a Kubernetes package manager. So with this utility, the command line utility, you can deploy the Helm chart. On the lower panel, you can observe the beacon node and validators are coming up. Let me move the window so you can see it more clearly. So one beacon and two validator comes up after you run one command line. And you can further check the version because I pointed to 2.2.0. Let's see if we run that version here. That's correct. So there are some other commands you can do. kubectl, basically it's the very popular and kind of official, it's open source, so yeah. So people develop it and it's a tool that we can use to interact with Kubernetes. So you can also run command like kubectl logs to get your application logs. So now we can see the beacon node syncing from your Kubernetes node. And we can also check the validator using very similar command, but check different thing. You can see it's awaiting activation and it's trying to get back to the beacon node, get the data and do the attestation. All right, so the next scenario I'm going to demo is how easy to upgrade your validator and beacon clients. So to upgrade, I just need to bump the version tag here. Here, I am assuming there's no breaking changes, so you don't require to update the chart. So most of the time, if just a minor changes, we can update the version tag here, save it. Also prevent from slashing. I'm now turning on the wait time. So you will see the validator won't kick off right after I deploy, it will wait for 2 epochs. Okay, so let me make sure I save this file. Then now I'm going to use Helm chart, the Helm binary again to upgrade the validator client and the beacon. So on the lower panel, you should be able to see they are being terminating. In our Helm chart, we configured that the strategy to upgrade will be recreate, which means that only when the old containers are terminated, then the new containers will come up. So this is an extra layer orchestrated by Kubernetes and can help us prevent from slashing during an upgrade intent. And as I mentioned, I turn on the wait time. So you will see now the validator won't become ready right after I deploy it. It will stay in the initialized state for 2 epochs or for the whatever wait time that you configure. It will wait for that long before it actually runs it. And finally, check the version. Now it gets to 2.2.1. And there is a third demo I want to quickly go through is the scenario when one machine goes down. So I will check the nodes currently that's available for you. One is worker, the other is controller. And as you may notice in the lower panel, we have 3 components deployed on the worker one. I'm going to issue the commands to terminate the node. So basically what I do here will kick off all the pods currently running on the worker one. And what Kubernetes will do next is to move the validator and the beacon to the remaining available node. So lower panel here, once again, things on worker are being killed. And the Kubernetes help us to bring up the beacon validator once again on the controller node without any extra orchestration for us to do. This will be auto-recovered by the Kubernetes. So just to do, hopefully this live demo can show you how Kubernetes can help you prevent from slashing and also take your burden from maintaining the your cluster, your nodes. And basically, once you have a stable cluster up and running, those are the benefits you will get out of the door. All right, so closing remark. We have the whole project available on GitHub, and this is the link to the slide. So supposedly you should also find other links in the slide as well. If you have some question, feel free to shoot us on Stakehouse channel in eStaker or just take my handle. I have left some final notes about how to choose Kubernetes distribution and do a little bit comparison, as well as the persistent storage option. So with that, I think we're about the time. Not sure if we still have time to take the question, but up to you, up to the host. And thank you, everyone.
Great. So 5 minutes, and we'll get going with the next. I feel very organized. Next up, me. So I'm Torsten. I'm going to talk to you a little bit about de-risking your staking client for post-merge. Maybe we can get my laptop up. Perfect. It's going to be partially a live demo and partially just me talking over some websites. I don't have slides. So what is this about? It's about diversity of the client. Right now, 100% of the blocks on the blockchain are being created by Geth. And that's relatively fine. If there was really a huge issue, people could patch their Geth, and you know, a new chain would be created, and a fork choice would bring us there, and it would be painful but not fatal. In proof of stake, however, this situation is relatively fatal. If you have a client that has a supermajority, meaning over 2/3, the validators that end up on the wrong side of it, once that bug is fixed, if there ever is a bug, right, they would either have to come back to the main chain, which would get them slashed because of a surround vote. If you listened yesterday as to, you know, the 3 levels of staking, what slashing is, it was explained there. Or, since they don't want to get slashed, they can get themselves into the exit queue. But if like 70% of validators are in the exit queue, it will literally take a year plus to drain, which means they'll all drain down to 16 ETH. It is not pleasant. So there were discussions around, well, it's too big to fail, right? If that happens, there'll be another DAO bailout. All core devs have already said hell no to that idea. Nothing is too big to fail. We will not do that again. We will not bail out the chain again. So let's not ever find out. That's where we're at. This is what this is about. De-risk your own staking client. If you're on a client that has less than 2/3 of the network, in this kind of worst possible scenario, what did just happen to my, there we go. In this kind of worst possible scenario, you're still fine. You're still validating, you're on the canonical chain. If your client has a bug and ends up on the wrong chain, it isn't finalizing because it doesn't have a supermajority. So again, you don't get slashed. You know, it's a little painful, but it's not terrible. So what I'm going to show you is how to move your, if you have a Prism Geth setup, how to move that over to a minority client setup. In this case, I'm going to use it with my own tooling called Docker, but this can be done on systemd just as well. So if you set up with like a Somer ESAT or a CoinCashew or a Metanol setup, those guys also have guides on how to stay in that setup and choose a different client. All right, where am I for time? Relatively good. So this is going to be relatively command line heavy. I have instructions here at docker.net on how to switch clients. So we're going to start with some Infura projects. They're going to really help us out. We're going to use them so we don't have to wait for sync from Genesis. There was a talk yesterday about that as well, about checkpoint sync. So I have these created over here, just the Eth2 or POS, proof of stake, and then a kind of Geth Eth1 proof of work going on. Once I have these, what I will do is I'll shut down the old environment, which in this case is set up to Somer ESAT's instructions. I will export the key. I really wanted to show you exporting the slashing database as well, but I didn't get that working in time. So there will be updated instructions once I have that working. For today, we're not going to do that. And then we're going to import all that into Docker and bring it up. So that's the demo. So what we have here is there is there's a Prism beacon service and a Prism validator service and a Geth running on this machine, again, set up in systemd through Somer ESAT's instructions. We're going to move it to Docker with a minority client. So first, I got to shut down Geth. This really is here so that I have disk space. In production, this would take like 700, 800 gig of space. You're going to spin up another one in Docker, which has to synchronize. You might not have the space to run 2 at the same time. Pre-merge, you can do this relatively easily, and it's not a problem because you can use Infura as a fallback while you're syncing. Post-merge, that's a whole lot harder. There are no fallbacks anymore. So we'll have to think about that very hard for how we do that post-merge, and I don't have a good answer yet. So let's start with, this is a Soma ISAD. We're going to disable Geth, this one right here. Okay. Go ahead. Oh, yes, too small. Thank you. There should be a... How is this? Is that better? Yeah? Reasonably visible? I hope so. All right, and we are, oh boy. Nope. Nope. There it is. All right. And we're going to brutally remove its database. Okay. All right. And with that, so Geth is down and its database is gone. I don't have that anymore. I'm now going to install an Docker client stack. I'm going to skip through this a little bit. This basically tells you what do I need to install. I need a Docker, I need a Docker Compose, I need Git. My user should be part of the Docker group, all that kind of stuff. That's already been done. So all I'm going to do here in this directory that I cloned is I'm going to do an ethd-config. And we're going to be on Prato testnet for this. And it's going to be an Ethereum node, so consensus execution and validator client. And we can choose our consensus client here. Anything but Prism. Do we have preferences? Anyone? Lodestar? All right, let's do Lodestar. All right, Lodestar. Has Docker Graffiti. What do we want for the execution client? Nethermind. Did I hear Nethermind? All right, that's the one that needs the most RAM, so that's going to be fun. So do you want to use a fallback execution client? Pre-merge, we can do this, and in this case, we will say yes, because this will allow us to get going while that thing is synchronizing. So I need my Infura URL here. It's going to be this client diversity demo here. These things will be shut down after, so I'm happy to show you these project secrets, because they'll be gone. We need girly. That's the trouble with 150%. You can see it, I can no longer. There we go. That's the one. Okay, we want the girly one, and we'll just delete that and paste it in there. Okay. And yes, we do want to rapid sync, please. So that's the same thing. We're going to go back here. We're going to go grab the, one more, the beacon project here for Prater. There it is. And Grafana dashboards, why not? Okay. So this is now configured and ready to start. What it doesn't have is it doesn't have the keys. The keys are still running in my Prism setup. So I need to get them out of there. And I need to make sure that Prism cannot start up again with the keys so I don't get slashed. Because I'm not moving the slash and protection database, I should also wait 15 minutes between shutting it down and bringing it back up. In this particular case, while that is going, I'm going to show you here, I actually never got my Prism fully synchronized. That was my mistake. I didn't load the Prater Genesis file. I forgot that was a thing. So it has been down for days anyway, so I can just bring it over. But if this was currently a testing, you would want to make sure that it's down for like 2 epochs, so you're safe, right? Okay, that's installed. Let's go over here and see what we're doing next. So make sure you have your key store files. I might have these key store files because I backed them up, or I just recreated them using staking deposit CLI. That's fine. But I can also export this. So I'm going to stop the validator client here. and export my accounts into a backup zip, like that. It'll ask me for my wallet password and ask me to select my accounts. So I say all, and I get to select a new password for these key stores. That's done. So that's now in a backup.zip file. Grab that file and bring that over to where a Docker wants it. So it's just an unzip. Yep. And I'm going to remove, for good measure, my backup zip file. Okay, so now I have the keys over there. They're not imported yet. They're ready to be imported. Still going okay for time. I already stopped the validator. I need to remove its entire directory so it cannot bring these keys back up again. This step is absolutely critical. If I forget this and the service starts again, I am screwed, as in slashed. So that's gone. And now what I'm going to do is I'm going to verify that that did the thing. What I'm going to do is I'm going to start the validator service. And what I want to do is I want to observe in its logs that it cannot find its keys. If during this step I see, oh, it's still finding keys, do not proceed, right? Could not open wallet, no wallet found. That's exactly what I want to see. That's great, right? So it's gone, even if the service starts because I didn't disable it or something, it will not get me slashed because it doesn't have keys anymore. So now I can stop it and disable it. This step I really highly recommend, no matter what you do, how you move, from where you move. Once the keys are gone, start the service again and observe that it truly cannot find them, because we make mistakes. You know, the copy paste is wrong, we forgot a thing, whatever, we make mistakes. Okay. We can also remove the beacon database now because we don't need that anymore, since the validator is down, so I'm going to do that. That's just the valid prism. I'm going to entirely remove the entire directory here. You can also remove these users that were set up. I'm going to do that here because I might use this again. And where was I? Follow the moving a validator instructions. So what I'm going to do now is I'm going to just do an SD key import. And it should, with a little bit of luck, import my keys for me. No, it does not. That is perfect. Okay. I am not sure what I did wrong here and why this might not work. Rename this. But if that doesn't do it, then I am going to be done with demo and just say I didn't prepare correctly. Nope. Don't know why. And I'm not going to troubleshoot on the stage. So I've got to figure out where that's going wrong. Theoretically now, I would import keys, do an SD up, and watch that happen. So right after this, I'm going to see why my keys don't import. All right, thank you. Do we have questions? Do you mind maybe moving a... Yeah? Who has a question?
Do you also support the beacon chain matrix endpoint?
I do, yes. Depends on the client. So Docker is a wrapper around the clients themselves. Lighthouse has that built in. I think for Prism, it's not in the Docker image. It would have to be source built to be there. And I don't think any of the other clients have it built in yet.
Anyone else? There you go.
When you rename the file, you didn't specify the directory. So you just moved it to your local directory.
Yes,
instead of...
correct. So the way it's meant to work in this thing is there is .eth validator keys where the key store file is now, and that is where the project looks for the keys when it's importing. I, of course, didn't test that with Lodestar. I tested it with Lighthouse, and so here I am standing, and it's not working. We'll get that fixed.
Anyone else?
No? All right. Well, thank you. Thank you, thank you. welcome. Thank you for being here so early. We're going to have Stefan from Stereum talk about Stereum development and past, future, present of the Stereum project. Thank you.
Ethereum is designed to be a decentralized trustless network of an almost infinite amount of participants. The number of services you needed to run in order to participate in this network at the time of launch was only one. There was only one service that you could run, and that was Geth. That's what we now know as the execution client. The execution client lets you manage your wallet. That means you can send Ether and tokens. You can also interact and create new smart contracts with it. Nowadays, Ethereum grew in a number of ways. One of these ways is the number of services you can run on, for, and with Ethereum. You can run a full node, you can run an archive node, if you can afford the storage for it. You can run a light node. You can also run a staking node in order to earn passive income with your own tokens, coins. Also, you can run DApps on these nodes. You can trust the network to verify each block and each transaction on the network. You can trust a centralized third party to manage your ETH and stake with them and earn rewards for you. And they also manage your earnings. You can also trust a centralized website to trade your assets and swap your NFTs. Today I talk about Stereum. Stereum is about running your own node. In the beginning of 2020, I read about Ethereum staking. And at the time, the most common used client for staking was Prism. Prism is still the most common used, although the use declined a little bit at least. I read up about how to use Prism and if there is any easy solution how to set up the Prism consensus client with an execution client to actually stake on a network. There was no solution. There was only little amount of documentation on how to connect the consensus client with the execution client. There was only or almost no information of how to properly interact with the consensus client to start staking. Medalla testnet, so therefore I created Prism Docker Compose. That's a GitHub repository. You can still look it up, but it's outdated. I wouldn't recommend using it for that reason. With this setup, I joined the Medalla testnet. The Medalla testnet was one of the early testnets before mainnet launch and was based on Gurley testnet of the execution client. Almost all of the validator accounts on this network ran on Prism. And I guess you can already imagine where this is going now, or you maybe even know the story. Medalla became unstable due to a bug in Prism. And Prism, the Prism team rushed to the rescue, fixed the issue and released a new version of the Prism consensus client. But that didn't resolve the issue, quite the contrary. It made everything worse. What happened was the Medalla testnet stopped finalizing, it stopped working, and it was unusable. What this event told the community back then was that you couldn't rely on only one consensus client, and that it is important to have client diversity to maintain a safe, stable, and reliable network. I learned from this experience that I couldn't only rely on one of the consensus clients. I needed to support a couple of them for my own good back then. So I dropped the support and the idea of Prism Docker Compose, which only supports one of the consensus clients, and I created a new one which was called Ethereum 2 Docker Compose. You can also look it up. It's still maintained, so you can run it on your own if you like. With this new setup, it was a little bit too much work for me alone, so Baisa joined the team. And with Baisa together, we created a Docker Compose setup that supported all 4 of the major consensus clients, namely Nimbus, Lighthouse, Prism, of course, and Tico. We also created a command line user interface. That's an ugly user interface that runs in an SSH session. It wasn't pretty to look at, but it did the job well, what we wanted to do. The first feature it provided was a setup that guided the user through the process of setting up and configuring a staking node. So you could choose to run either a execution client yourself, in this case Geth, or rely on a third party like Infura.io. And you can choose one of the 4 consensus clients. It also installed some monitoring solutions like Prometheus and Grafana. But that's basically it. It set up a monitoring, a staking node. After that, we also created an import in this CLI UI that lets you import the validator accounts into these consensus clients with the same workflow. You started the command line UI, specified where the keys you want to import are, and import them. The process for all 4 of them is the same. Users didn't need to look up anymore how to interact with one of these consensus clients at a time. They had a solution for all 4 of them. After that, David joined our team. And with this, with our 3rd team member, we created a graphical user interface. The graphical user interface is still maintained to this day. It has basically the same feature set as the CLI UI. But on top of that, you can do more with a commonly used graphical user interface than you can do with a normal command line interface, user interface. So there are some checkups like operating system, do you have enough storage, and so on and so forth. The goal with this was to create a solution there was no need anymore to touch the command line interface. You just downloaded the Stereum launcher, that's what we call the graphical user interface, and pointed to an SSH server that we support, namely Ubuntu and CentOS. The Stereum launcher itself runs on almost every desktop. It runs on Windows, it runs on macOS, it also runs on Linux. The initial setup was about 30 minutes long. So when you start the Stereum launcher until you have a running node, it only takes you about half an hour. The chain, unfortunately, grew a little bit longer over time, the beacon chain namely. And with that, also the sync times went up significantly. We came up with a solution that we call FastSync. FastSync basically copies an existing database of the blockchain to the user's consensus client and installs it in the correct path, and also makes sure it is correctly configured. With that, the consensus client can then pick up where the backup was left off and just sync to the head with only a small amount of blocks remaining. That usually takes 10 minutes or even less. Of course, also the graphical user interface installs monitoring solutions like Prometheus and Grafana. It also installs a dashboard according to the consensus client that you chose. And it also installs another dashboard that lets you monitor the CPU usage and storage and so on. Furthermore, we have an app available for iOS and Android. Both of these apps you can connect to your Stereum node, and you can receive Grafana notifications on these nodes, on these mobile apps. Tim Baker said on the Ethereum day on Monday, that on his talk about the roadmap, that on his view of the network, the Ethereum client is now, after the merge, will be two services. There will be the execution client and the consensus client. So to actually have full access to all the data of the network, of the blockchains, you need to run already two services instead of one. A service is some kind of a program that acts or interacts on user input and produces some kind of output. And these services got APIs, they got connectivities like peer-to-peer network. They also got CLI commands and furthermore maybe UIs, user interfaces. The average user doesn't care about how to connect them. And you need approximately 6 to 10 services for a staking node to get the maximum amount of output of your validator accounts. And we can't really blame the users who don't care how to connect these things, because most of us don't know how to repair a combustion engine, yet we still drive cars. Most of these services also support some kind of API specification. These API specifications get drafted through thorough work with sometimes lots of teams interacting with each other and finding a solution that fits all of them. What this means also is they change over time, also because of Ethereum gets developed further and further. One of these examples is the beacon chain API that lets you interact with the consensus client. This API changes constantly. You can look it up on GitHub. The API specification of this is up on GitHub. And there are still pull requests open, and it will change all couple of days. Ideally, first comes the specification and later the implementation. But that's not always the case. We saw this with the import procedure of the consensus clients when dealing with validator accounts. All of these consensus clients currently in development have a different approach on how to manage, import, delete, exit, whatever, you name it, validator accounts. Now we have a specification for that, thanks to James from the Prism team, who initiated this specification, and they try to implement those to the best of their knowledge. The point of this is not everything is specified up front, and different teams or people come up with a different solution for the same problem. That's not necessarily the bad thing. Actually, that's what Ethereum is all about. On the red area, you see what Stereum 1 covers. It's basically a solo staking node setup. We will keep maintaining Stereum version 1, even after we release Stereum version 2. The green area you see is what Stereum 2 covers in a couple of months. And we won't stop there. We will cover more services, more operating systems, and more use cases along the way we move forward. We don't track any user data. Stereum doesn't care about your behavior, or how you use Stereum in any way. The only interaction you have with us is you download the Stereum graphical user interface, the Stereum launcher, and that's it, basically. Although we support our users through Discord and email and other means of communication like Telegram, Twitter, and so on. And someday we got chat up from some guy who got a minor issue with one of his mainnet nodes. He ran multiple. mainnet nodes with Stereum. And it was just a minor issue, so it was a quick fix, but we kept in touch. He provided some really good feedback and also reported some more minor issues over the time of our conversations. And after some time, he reported a really interesting one, and that was an issue with the validator account list. Usually people have, or users have, the same issue with the same component. And this was new to us. We didn't got any reports of any issues with the validator account list. So I was curious already. And we started to investigate, and it turned out that he ran a 3-digit number of validator accounts on his Stereum node. So just to clarify, this is 100 plus keys on one of his Stereum nodes. That was very surprising to me, that Stereum is used to manage this amount of funds. We get questions and also feedback out of the blue from nowhere. People message us, or mostly me directly, about some issue they have or some feedback they want to provide. We have no means of tracking user data, so we don't actually know how many users use our solutions. And still people come up to us and tell us they know about our solution before, like the Ethereum 2 Docker Compose, when there only was the CLI UI, or even before when there was the Prism Docker Compose. So not only do we underestimate the amount of people who run actually Stereum, because they don't like to be in public, or they don't feel the need to be on our Discord server or something else, but also the assets that Stereum manages on nodes across the world, across the network. So we decided that we need to do this better and come up with a better solution than Stereum 1. Stereum 1 lacks flexibility. Its only use case is mainly solo staking, and that's it. And it was back then when the idea of Stereum 2 popped into my head, that needed to be more flexible and covers more use cases. But let's go back to the car driver again, to the average car driver. The average car driver doesn't know how to repair or even build a car. Yet they want to go from A to B. And the funny thing about cars is you still can fix them on your own. You can get the tools for that. You can get the knowledge for that. Most of it is on YouTube. You can even get the machines to get your own make your own spare parts. It's something about the same about the average Ethereum user. The average Ethereum user wants to use the network and not care about how to connect the consensus client with the execution client, or what services are needed to run in order to have the maximum output of your staking node. That's when Stereum comes in. It simply runs your node. You can still modify it, you can still look at the code. Everything is open source, what we do. You can even release your own version of Stereum. But there is no need to it, like with the car. One further example is swapping out the tires of your car. And it should be as easy swapping out the tires like swapping out your consensus clients of your staking node. Stereum version 2 will provide solutions on a use case basis. Stereum 1 covers, as we saw, mostly solo staking. Stereum 1 will only be a part of Stereum 2, and we will try to cover more use cases with Stereum 2, like SSV, multiple SSV networks, rocket pool integration, and of course DApps. It also provides a faster setup, because the graphical user interface that comes with the Stereum 1 is installed on the node itself. With Stereum 2, everything about graphics is in the Stereum launcher. So there is no need to install the whole UI on the node. It is for that reason that it's also safer to use. It also provides basic monitoring. As I talked earlier about the monitoring of Stereum 1, we already have a solution using Prometheus and Grafana. We will provide some metrics also without these components to give the user an idea of how his node is behaving without running certain monitoring solutions on that. But we still don't prevent the user to install those, and we will also support enhanced monitoring with Prometheus and Grafana. Also the mobile app, which will be much more integrated into Stereum in the future. We started with the Stereum 2 development end of last year. And the vision was a maintenance-free Ethereum node, which covers most use cases average users think about when talking about Ethereum. For this reason, we started with developing the backend first. And this needs to be as reliable as possible to make the experience as best as possible, because nobody likes their decentralized node offline. For this reason, we also run lots of VMs at the time now to improve the setup and make sure every change we do at the backend is not affecting any of the use cases in a bad way. The goal is not only client diversity for consensus clients, but also for execution clients. I talked earlier that there are like majorly four major consensus clients. With execution clients, it's the same thing. We have Geth right now that covers like close to 90% of the nodes. And we want to also introduce some other, like Nevermind, to this setup, to get people to use these too. Also, we will cover more than one of the SSV networks, because we feel competition makes a big part of the pressure to make things better. As I talked earlier about the 30 minutes that takes, that's the time of starting a node. With Stereum 2, it comes down to 3 minutes. Although this doesn't cover the fast sync, because together with Attest.io, we want to implement a new technique, a decentralized technique of hooking into the blockchain and syncing not the whole blockchain, but just a few blocks left. That's what we will call sync link. This will provide an almost instant setup of an Ethereum node. One key feature that I like the most is we will introduce new languages to Stereum. Only about 20% of the world population speak English. This means they know it as a first, second, or third language. We will support up to 9 different languages to make it possible for people not very good in English to run and get access to the Ethereum network. Really? No. I think I have 45 minutes. Yes. Thank you very much. So this is how Stereum 2, our first release, the alpha version, looks like. We had a booth, up yesterday at the 8th floor of this building, and we got some great feedback on this already. But let's have a look at it for all the people who didn't visit our booth. This is the first UI you see when you start up the Stereum launcher. It provides you the possibility of saving and, of course, loading the saved connections to your servers if you run multiple. We enter the credentials and click Login. Das will mich nicht. Here we got the welcome screen that basically lets you choose how you want to set up your node. One of these possibilities is the one-click installer. That's the left one that we will showcase in this case. It will provide the user with information of how to set up the node. You also see it checks already the operating system in the middle. Then you can choose which network you want to run on. You choose the use case you want, and you can already see the staking setup chose Nimbus for staking. You can edit some settings of this setup. And then it installs it already. With the login node, with the login screen, you already saw that you can manage multiple servers, not only having one server available, but you could run multiple staking nodes, maybe one node for staking, one node for your DApps, one node for an archive node. Now the operating system is updated to the latest system packages. Some new system packages get installed to run the Stereum node. And as mentioned, there is no UI installed because we already have the UI in the installer itself. Nimbus is known for having only a beacon service. For that reason, we also display a validator service for the user to clarify that you don't need to run a separate validator service if you run Nimbus and want to stake with it. It is shown as a part of the Stereum setup. There are other consensus clients like Prism that run a beacon and a beacon for the consensus client connection to the network and a separate validator service. To the user, this is shown as the same way. However, if you look deeper into this will be displayed transparent to the user. So the user knows that it's the same service that runs, but has provides different functionalities. Here we have now the node screen. You can see that there is a consensus client installed, namely Nimbus, also the validator, also Nimbus, and the execution client, which is Geth in this case. It also installs monitoring solutions with Prometheus and Grafana. We also see that you can already delete the setup. That makes our testing easier. What else does Stereum do for the Ethereum ecosystem? Well, with our work with Stereum node setup, we push for decentralization. Our goal is for everybody to be able to run their own node on their own hardware, having the keys for that and not relying on third parties to run your node or to provide services that access the blockchain. In the process of that, we break things regularly. Mostly it's our fault, but sometimes we come across issues that are actually bugs in consensus clients or other services like SSV clients and so on. And with this feedback, we go back to the development teams of these services and provide a different and help of improving their services and stabilizing it more. Also, we are on some funny staking challenges, namely the upkeep and uptime challenge. You can participate with your validator account, and you earn a badge in validating, in participating. You can also earn NFTs, win NFTs if your validator account participates on the network very well, has a high efficiency. And we also have some physical prizes. But you can look into that if you scan the QR code you get to the website, and you can look into that further. Stereum is also on YouTube. We provide some interesting insight into how we develop Stereum version 2, and also some updates on the Ethereum ecosystem. Last but not least, we still have some socks available that we didn't give away on our booth. So if you are interested in some funny socks, you can come up to us after the talk and yeah, I see some interest there. And earn some free socks for being here. Also, I want to thank the ETH Staker community for having us today and making it possible for us to have this talk. See you.
already there. So thank you for being here. We will have Lansky from DAppNode show us how to do multi-client with a UI and switch easily between clients. This is quite exciting. DAppNode for the longest time could just do Prism, and now it does multiple clients. So please join me in welcoming Lansky.
All right. Let's plug this in. That's not the one. All right, something smaller. This one's even bigger. There we are. Good. All good. Beautiful. So what are we seeing there? Perfect. All right. Cool. So I like to walk around. Perfect. All right. So switching between clients. So as you know, we've had a little bit of a problem with Prism supermajority. There was Prism was more than 66% of the network, which meant that in the case of a consensus bug in Prism, we basically sent the entire beacon chain to shit. DAppNode, so we've had a lot of pressure from the DAppNode staking community for trying to bring multiple clients into DAppNode and for people to be able to validate with multiple clients. The thing is, it wasn't that simple. It wasn't that simple because every single client had their own standard. It had their own API, and there was no way there was no UI for users to use simply with that. They would have to use command line at some point, and that's not what we want to do at DAppNode. DAppNode is a tool. We've seen Stereum before. DAppNode is a tool to make it extremely simple for everybody, regardless of their command line abilities. And we wanted it to be without command line, the simplest that you can do. UI, click, click, you're staking. So, for those who don't know DAppNode, is there anybody that doesn't know DAppNode here? Everybody knows DAppNode? Oh, you guys. Cool. So the mission is to create a human-centric, decentralized hardware infrastructure network, basically to create a network of people running their own nodes. This is important. It's actually in the design goals of Ethereum 2. And this is illustrated with something called the correlation penalties. So in the protocol of Ethereum 2, there's such a thing called correlation penalties, which means that if many clients are offline or receive some sort of penalty at the same time, this penalty is multiplied according to how many people were offline or had the same penalty at the same time. And this is meant to disincentivize everybody staking in AWS, for example. So if AWS goes down, you will not only get penalized by the time that you are down, you'll also get your penalization multiplied by every single other validator that was also in AWS and was offline at the same time as you. So this is a huge case for solo staking as well, and it was implemented in the design goals or in the protocol of Ethereum 2. So why, apart from not getting wrecked, why is it important to be decentralized? Because it's important that we have our validators and our nodes under different political jurisdictions. If a government decides to make it illegal in one country and all the servers are in that country, let's say the US, Ethereum is going to have a hard time. But if we're all decentralized and they cannot trace where we are because we're running in home setups, then it's all good. Different geographical locations in case there's a power grid outage or whatever it is. Different ISPs because ISPs can block specific types of traffic. Different hardware because there might be a zero-day bug in some firmware in a specific part of hardware. And especially different ownership. We need different ownership because in Web 2, it's always the same 5 companies that capture all the value. in Web3, we have the potential to participate in the capture of this value. After the merge, every transaction fee that gets paid in Ethereum will go to a random person that might be running their validator in their own homes. They are validating, they're securing the network, and they're participating in this 100 billion moving around. Cool. So those stats are from ETHDenver. They might be a little bit out of date, but there's more than 2,700 validators on DAppNode. That's about 250 milli, a quarter of a billion on DAppNode. Not too bad. Around 30K DAppNode graffitis, and we estimate that we have like around 0.91% of the network. Important point here. DAppNode doesn't know who runs DAppNode. This is all self-reported. This is all self-reported by putting the word DAppNode in the graffiti. Okay, we have no idea, we have no telemetry, we cannot possibly know who runs a DAppNode, unless you buy it from us, and then, even then, we know that you've bought one, not that you're running it. Cool. So now that we understand a little bit what DAppNode is, let's see a demo of switching clients. So this is DAppNode. This is the UI of DAppNode. When you have DAppNode in an Intel NUC, for example, in your kitchen, connected to your router, once you VPN into it, this is what you see. You see the Dapp store, and you can download packages here. You can download an archive node, an Aragon node. You can download whatever it is. Before, you had to stake with Prism. You had to go to Prism and stake with Prism because it was not the only client that had a UI. Give me 1 second. All right. So before, actually, let me explain a little bit what happened before. So before, you needed to put the keys in the Prism package, which connected to its own beacon chain, and then you would start validating. You create the key stores with the launchpad, etc., put the keys here. And if you wanted to switch clients, well, you couldn't with the UI, but you could manually do it by removing the keys from Prism, putting them into the Lighthouse client or whatever client you want, and you would start validating with the Lighthouse client. But what happens if you forget to remove the keys from Prism? Well, then you have the keys validating in two places at the same time, and you get slashed. So this is why we couldn't possibly let DAppNode users do that by themselves. There was no UI, and it was not safe. It was not secure. Everybody has a bad day. Everybody has a day where like they don't know, and they're doing things quickly, and they're like changing these, and like we needed to make it programmatically impossible for them to get slashed, to lose their money. It's extremely important for us that everybody that runs a DAppNode knows that no matter what, they will not get slashed. So, new approach, Web3 Signer. Web3 Signer is a piece of fantastical software by the Consensus team. We developed, with DappLion from our team, we developed, and the collaboration of every single client implementer team, we developed the Key Manager API. So once the Web3 Signer and different clients had the Web3 Signer, the Key Manager API implemented, now these pieces, the different pieces, can speak to each other to manage keys, to manage the keys and import keys, export keys, and you can basically create a UI that will tell every single piece of the puzzle to do what with the keys. So with this Web3 Signer, you just put the keys in the Web3 Signer, thanks to a beautiful UI that we will see in a minute. And then you just tell the Web3 Signer, okay, point to the Lighthouse validator client, or point to the Teku validator client. And that's it. It's as simple as that. The keys are never in two places at the same time. The Web3 Signer maintains its own slashing protection database, so it's impossible to get slashed. And Joachim made a beautiful UI for the Web3 Signer as well. It's very bare bones, very simple, but it works. So let's see how exactly it works now in DAppNode. So we can see that the Web3 Signer, we have it here. It's already installed. And let's see the UI. So we can see this UI, and we would go here. Is it big enough? We can see here, this works in Prather at the moment. So what we have is we have Lighthouse Prather, we have Prism Prather, and we have the Web3 signer. When you install the Web3 signer, it'll ask which client implementation do you want to use. It'll have this drop-down menu. And you choose one. Let's choose between Lighthouse and Prism, because those are the ones that I have synced. Okay, so we're going to choose Lighthouse, which was already chosen. And we can see here in Lighthouse that it's pointing here. So now, we would go to the UI of the Web3 signer and import the key stores. Just drag and drop the key stores. Import slashing protection data or not. Actually, let's maybe do that. Perfect. Let's put this key store here, which is already one of those. So let me eliminate them. Delete key stores. Perfect. Oh, beautiful. Okay, so cannot delete. Perfect. Good testing, live testing. Beautiful. And then you would import the key stores by doing this. They're already imported. Just drag and drop and put the key store password and you're in. Okay? So they're already imported. Those are the same. And then if we look at the Lighthouse, we can check the logs, beacon chain. Let's check the validator. And starting found public keys. Beautiful. Let's actually have a look at what happens with the Prism. Let's look at the logs of the Prism validator. Client not authorized to access the Web3 signer API. Oh, okay. Sounds good. Cannot get slashed because it's not authorized. So now we're going to go to the Web3 signer. And we're going to change to Prism. Updates. Okay. Let's see what happens in the Lighthouse logs. What's happening here? Lighthouse logs. Those are the Prism logs. Updated Web3 signer. Oh, okay. So Lighthouse logs. Stop validator. Validator stopped. That looks good. We're not going to double sign. And here we go. Here, fantastic. Waiting for beaconNode to sync. Beautiful. So now, once Prism is synced, we will move to Prism. But remember, we don't want to move to Prism. We want to move out of Prism. So let's go again to Lighthouse. Or actually, let's try to do something crazy, okay? Let's try to install, let's try to move to Teku, which is not even installed. This is all in testing. Okay, let's try to go to Teku. I will just get it manually. There we go. And we're going to use this API key for the checkpoint sync that will allow us to start validating immediately without having to sync the entire beacon chain. Prism doesn't have it, so we need to wait for it to sync. Now let's look at the metrics. Let's look. So DAppNode also includes a metrics package where you can see everything that's happening. And we have our dashboards here. We have the Web3 signer dashboard. And we can see that we have 2 loaded keys, which have done 0 signatures because they're not activated yet. And voila, that's what we would see. Let's look also at the Lighthouse validator clients, peers, memory, distance from Genesis, voila. So we've got all of these beautiful things that you will have just at one-click install. You've got all the monitoring, you've got all the everything that you need, right? So Lighthouse, we're here. Going back to the Web3 signer, actually. I think I'm stressing my DAppNode out. Is the internet connection okay? Hello. Beautiful. Okay, so we changed it to Teku, and Prism stopped validating here. Okay, it's also not validating on Teku because we don't have Teku. But we can go now, if it lets me. Well, we would go to the Web3 Signer UI, and we would change it back to Lighthouse, and we'll see that Lighthouse would start validating again. So basically, long story short, we've got a beautiful UI to import the keys. We've got a way to change from one client to another. Let's change it back to Lighthouse, for example. And that is impossible for any DAppNode user to ever get slashed by switching clients. And thanks to the magic of checkpoint sync, we will be syncing like basically 2 minutes after. We will not need to even sync the entire beacon chain. So if we see Teku, let me try to show you how that would be synced already if we have used the checkpoint sync, which is here. So let me try again with the Web3 signer. Update. Teku. Let's go to Teku's logs. And as fast as this, we didn't even have the Teku package. As fast as this, syncing completed, it would start validating here. Like, that's how easy it is to change clients. Wild. This wouldn't have been possible without the client implementer teams implementing the key manager API, the Web3 signer team also working next to us, and Joachim, who is now in Web3 API, I think. He was former Android lead at Twitch, and he wanted to get into Web3 and started collaborating with us on this. So big props to them. It wouldn't have been possible without them. This will be live in mainnet as soon as we finish the testing. Some kinks there, some little errors that have happened, and as soon as Prism implements it in the main branch. Right now we're using the develop branch, but it's working in Prather. Help us test it. And it will happen first in Gnosis Chain. We'll start multi-client validation in Gnosis Chain as well, so you can validate Gnosis Chain. And right now you can only do it with Prism, but we will go live on a mainnet, on Gnosis Chain mainnet, before we go onto Ethereum mainnet. And that's following sort of like the trend of the Gnosis Chain to be like sort of like a canary network for Ethereum and trying things before. So if people lose money, if this has to be tested in production, let's better use it on Gnosis Chain, where the risk is very low or lower. But there's still something at stake, so you really don't want to fuck up. But then we can move onto Ethereum. And that was pretty much it. That's how to switch clients with a couple of clicks, never using command line on DAppNode. If you want to know more, discord.dappnode.io, or follow us on Twitter @DAppNode, and happy staking.
And then we gotta get ready for the next speaker. Anybody? Nope. I know my explanations are good. They are very good. They are the best. Okay, thank you. Thank you. Thank you. All right. Last presentation before lunch break, and thank you for being here for it. We're going to have Diego Lozado and Fernando from the Ethereum on ARM team, and they're going to talk to us about staking on resource-constrained devices. Resource-constrained means things like a Raspberry Pi 4, like this little thing almost literally powered by a banana. So I'm really looking forward to this. They're going to be on Zoom, hopefully soon. Can we get them on there? There they are. Okay. Please take it away, guys.
Hello?
Yes. Yeah.
Oh, it's, yeah? Hello? So, could anybody please confirm me if there's sound in the room?
We can hear you, so you can...
Okay. Okay, we can hear now. Can we start? Okay. Okay. Well, thank you very much. My name is Diego Lozada. I'm here with my teammate Fernando Collado. And for those of you that may not know about our project Ethereum now, our main goal is to contribute to the decentralization of the Ethereum network by providing these plug-and-play images for resource-constrained devices like the Raspberry Pi. No? What we're going to do today is to set up a staking node from scratch. So let's share some info first. We cannot share our screen. We are not allowed to share our screen. Could you allow us, please? Okay. Desktop. Yes. So let's go to. Okay. So no, it's not necessary. So some info of our images. They are pretty much plug and play. You don't need to configure any client or set up any configuration. Just you just need to flash an SD and you are all set. Currently, there's only one image for the Raspberry Pi, and more devices coming this year. We'll get to that later. And we've been staking on a Raspberry Pi. We actually have 3 validators, and from day 0. So this works. This is tested, and let's go to the demo. Just some considerations. For staking on this kind of devices, you will need some Linux skills. I mean, it's not extremely necessary, but yeah, they're appreciated. I mean, some knowledge of command line. If you are going to stake, which is a serious matter, you should have some knowledge about this. We are going to use the wallet testnet for obvious reasons, and our AWS image for convenience, because it's very easy to use for us, and it's pretty much the same image that we use in the Raspberry Pi. And we are going to follow our portal, so you can recreate this easily. So we are going to show you our documentation and do a walkthrough. Okay. So you have to download the image and uncompress it and flash it into the SD card. You have it here.
You could click the link and test. The main issue here is you only have to download one file, one small file, not so small, but one file, and compress it and save it to a small SD card, like a typical SD card you could have in your phone. You at least need 16 gigs for the SD card. Once you have downloaded the SD card, and you have to flash it to. Once you have downloaded the image, you have to flash it to the SD card. You could use DD, this command line, like Diego said before. This one command line, you only have to tell the command line which image you have to use, this ARM image, and the very important thing here is to choose the right device you need to write into. That here in this case is SDD, but could be another name. It depends on your computer. That's the key here, because if you flash it in another device, you could do some very bad things to your own computer. Once you have it, you only have to put the SD card in a typical Raspberry Pi. I don't know if I could get in focus. Here, something like this, and put the SD card in the Raspberry Pi, and you have to plug an external SSD to the Raspberry Pi. And it's very important to choose the blue port, the USB 3 port. That's the only problem you could have is choose the wrong port. And now you're done. You have to plug it to your network with an Ethernet wire, and you're good to go.
You just need to wait for a few minutes. In the Raspberry Pi, it's about 10 minutes. And the script installation still performs all necessary tasks and reboot the Raspberry Pi. So you can connect to it and start using the Ethereum clients. Let's see.
I don't know if people can see the letters, so we have to increase the font.
Sorry,
I can't hear anything.
Okay. So there are instructions of how to, if you don't have a touch monitor, how to connect to the Raspberry Pi, and default user and default password. So you need to change that. It's pretty straightforward. And after that, you can connect. Here we have this is absolutely the same. We are in AWS image. We have an image, so it's pretty much the same. It only changes the device, but the image is absolutely the same. So what we need to do now is enable an L1 client, now called the execution client. So it's we already have done that for the demo. You only need to enable a system service. For example, with that, as you can see, we are using here the early. We can see a lot still. So as you can see, this the execution line is already synced. Okay, and this is pretty much what you have to do to run an Ethereum node. Just start a systemd service. You can pick up. We later will see this in the launchpad. There are lots of execution clients to choose from. You only need to pick up. It's all installed. So now, once it gets synced, we need to start a consensus client. In our case, we have chosen Nimbus. So the command will be this. Okay. We already did this. It's not synced yet, but it doesn't matter because the only pending task would be create and import the validator keys. Let me show you the logs. You got it. So there are no validators yet. We will get into that later. So let's go back to the documentation. I don't know. Time is it up? Let's go to now. We have here Nimbus. As you can see, there are instructions for every client, both F1 and F2, now called execution and consensus. So what we're going to do is now create the validator keys. So for this, we need the official tool from the Ethereum Foundation, which is exactly this, but we are going to use Prater in this case. We need the Ethereum account, not root. Important. Let's start with Prater. So this is going to create the validator keys and a deposit file that we later will use in the launchpad. Let's put here type password. This is the mnemonic phrase. It's important when you do listing mainnet, but not important. Absolutely crucial to write this down to save this in a place. Okay. Let's now we are creating the keys. I need to store here, as you can see. Oh, there were another ones. Let's repeat this. So sorry about that. And
I think it's important to notice that all these tools are available in the image. There are several different packages maintained for us. You're going to use it in a big easy way.
So now we have our key store and the deposit data. We will later copy to our desktop and use it in the launchpad. Okay. Now let's go to the launchpad. This is here for product. Yeah. We choose become a validator. There's a lot of info and warnings here. You need to read this. Okay, we are going to skip. Yes. Yeah. Okay. Now, as mentioned, you may choose any client. I mean, this these four are available in one image through systemd service. So you only have to start a service. It's all in the documentation. You can go through this. We can skip this. It's about installation. Same for consensus clients. All four are available in the image. We are using Nimbus in this case. So again, we can continue. Here is more informative. You can choose how many validators you want to enable, and the system tells you how many you need. Both in this case. And here we have to choose which tool you want to use for taking the keys. As Fernando mentioned, we already have this installed, so you don't have to do anything. We already created the keys. So let's check this. Continue. We are going to now copy the deposit data here. You can do for example, do a cut here and copy and paste in a new file in your desktop. It's all explained as well in the documentation. So we have now here the file. Is this one? Okay, and now the only remaining task would be create the transaction, which we don't have the OS for doing this, but no, it's pretty straightforward. I mean, it's easy. Just doing the transaction, and the validator gets enabled. Well, it's queued, and then later is enabled. So as you see, pretty much all the software is installed, and you can enable a validator fast. I mean, the only waiting time is for the chain to sync, both forward 1 and 2.
The main idea is you have a very easy and straightforward way to do it with a small device and low power device like a Raspberry Pi, and another future device that Leo is going to tell us. But we are starting to work with different new smaller and devices like new algorithm, probably a Rock 5 in the next weeks. We are just
Rock 5 is very interesting because it has 16 gigabytes of RAM and NVMe support, which is great for lanes. And it's very, very, very interesting because of what we're testing for the merge. And speaking about that, we have available an image. I want to mention this for Kill. So I encourage you to download this image and join testing the merge, because it's great to start playing with how Ethereum will be in the next months, and particularly for us, how it will run this kind of devices.
And if you don't have a Raspberry Pi, you can use your
you have available as well
AWS image.
AWS, and you can test it in there. I think that there is a mainnet AWS as well, but this would be quite expensive. I don't recommend this at all. But for testing purposes, I mean, it's maybe you want to run a testnet or a private network. you could use it as well. But we encourage to use Skin because it's important for developers to get feedback for people running on real hardware, and this is a very easy way of doing that. And I think that's it. I don't know if you have
Okay.
any other
question. I didn't hear anything.
No. Okay.
I don't know if they are hearing us.
Can we get this mic? Perfect.
Yeah.
Can you guys actually hear us here?
Very, very low.
All right, perfect. So we're gonna see whether we have audience questions.
Okay.
Anyone? Going once, going twice. It was super clear. There's someone. Okay, here we go.
Will it be more difficult to run on Raspberry Pi post-merge? What do you think about it? Are the requirements increase or not?
Tough to say. My understanding is that it will be a little tight with 8 gigabytes of RAM particularly. But, as Fernando mentioned, this year some devices are coming out that with 16 gigabytes of RAM, and I think we will be able to run both on the same device. I think it would be very safe to run a consensus client in one Raspberry Pi and an execution client in other.
The teams are doing a great job improving the memory consumption of those clients.
Yeah.
Particularly, I don't really know, but I have the feeling that it would be possible to run.
It could be. For example, Windows is able to run a consensus client with less than 1 gigabyte of RAM. So yeah, it will be possible, but I think it would be a little tight, to be honest.
Follow-up question?
Yeah, the follow-up question. You have tried Kiln, right? But are you planning to try it out on one of the mainnet shadow forks?
And not yet. We will try the result of yes.
All right, thank you. I think we're breaking for lunch here. Thank you for the team of Ethereum and ARM.
Thank you, guys.
Thank you, guys. Okay, bye.
so should I begin? Go for it.
Very quick. So thank you for coming back after lunch. I hope you are still awake. We'll have JK from stake.fish talk to us about liquid staking options. Thank you, JK.
Thank you. Hey everyone, thanks for coming here as opposed to Jim McDonald's great talk about beacon chain clients. Definitely not a talk you would want to ideally go up against, but nonetheless, I promise I'll try to make it as interesting as possible. First of all, thank you very much to the eStaker community. I think eStaker is like one of the reasons why we have a lot of these developments and discussions around why decentralization is important on eStaking, as well as trying to push for client diversity. All of these initiatives would not be there if it were not for eStaker. So really appreciate the eStaker folks for inviting me out here. But today, there were a few topics I was trying to think through about what I could be discussing about, but I really settled on trying to discuss more about liquid staking. The reason being because there's a lot of focus currently on liquid staking, obviously, and I'll go into why and what the architecture for liquid staking is, but there's a lot of also new up-and-coming liquid staking protocols. Lido, without a doubt, I don't even need to talk about how dominant they have been, and Rocket Pool is of course coming up very quickly. And there's many more others that have not launched yet but are preparing. And I've talked with a few of them, I've talked with most, but there were definitely a lot of thought process I think we're not being put into yet about how what they need to do in order to actually compete with Lido. So the goal today here is I wanted to dive into liquid staking, architectural designs, some data points about their use case, about why Lido is so dominant currently today, and hopefully this provides some pointers to new up-and-coming liquid staking protocols on how they could try to provide a real competition to the dominant player Lido today. Just as a disclosure, stake.fish is a big operator on Lido, so it's kind of weird for me to say competition against Lido, but I'm a big proponent of competition. Competition creates the best outcome in any market, so that's why I want to see new liquid staking protocols actually really drive. So let's start with liquid staking basics. If you were part of the talks for Rocket Pool or Lido today, this might be a bit more familiar, but I'll just try to run through these very, very quickly. So why do we need liquid staking? On Ethereum, as most of you are aware, you need 32 ETH, and you need to lock these up in order to earn staking rewards. For as long as that 32 ETH is locked up to earn staking rewards, you can't transfer that out. It's totally locked. And additionally, as another, a constricting factor, because of how Ethereum is migrating to proof of stake in phases, until withdrawals are enabled, it's effectively just locked. You can't unstake it. You can exit the stake, yes, technically, but why would you do so? Because why would you even do that? So it's as easy, for me at least, it's as easy as saying there's just no unstaking possible currently on Ethereum today. And so given those restrictions, that's exactly why liquid staking was developed. In order to first let people with less than 32 ETH to be actually able to stake. And on top of that, to give them a way to actually transfer those locked staked 32 ETH tokens. And so I pointed those 2 points out, and then enter liquid staking. And of recent, we've seen adoption for all of this really spike up crazy. I've put together 3 charts. I've pulled 3 charts that Elias has put together on Dune Analytics, and it shows at least of the liquid staking protocols that are listed there, like the hypergrowth we've seen on Lido, Rocket Pool, as well as Stakewise recently as well. And so, without a doubt, I don't need to. I don't need to really go into depth about how much the markets as well as the market participants are looking into liquid staking protocols. Let's go very briefly into the diagram of how liquid staking works. You start off with ETH, of course, and you stake that to a smart contract, which then allocates those ETH out, the 32 ETH out, the ETH out to each of the validators. And then afterwards, the rewards are accrued in a new type of token. You see that circle ETH over there. I tried to represent it as a wrapped version of the ETH. These tokens go by all different names. I'll go into how the token model works on the next slide. But roughly, like after the ETH is allocated to each of the validators, the rewards are accruing basically to a new type of token that is issued by each of the liquid staking protocol. And then at the end of the day, of course, the end users are earning the rewards. Now, throughout this design, each of the liquid staking protocol has very unique differences on how they architect, how they design liquid staking. There's a lot of details that we could go into, but roughly I've taken out two important design choices. One is going to be the tokenization, how the liquid staking protocols choose to tokenize the staked ETH. And then secondly, how do the liquid staking protocols think about onboarding operators? So starting with the tokenization aspect. So I've taken three protocols. They have roughly, I think, the most representative choices that most of the new liquid staking protocols are taking. The first off is starting with Lido. And Lido, if once you stake ETH, you get ST ETH back, and this token is basically a rebasing token. As long as you hold that ST ETH in your wallet, you'll see the number of ST ETH constantly grow on a daily basis. And this is what we call rebasing, and that's how Lido accrues rewards to anyone who holds the ST ETH token. Rocket Pool is slightly different. In Rocket Pool, the token, the RETH token is totally fixed. The moment you you stake ETH to receive RETH, that's the number of tokens is not going to change afterwards. What changes is that behind RETH, when you try to redeem this for Ethereum later down the road when we're trying to withdraw, you'll see that the number of ETH that you could redeem for is constantly increasing. And so you can see rebasing versus fixed supply. There's like a very significant difference on how these two protocols are approaching it. And then last but not least, Stakewise also has a very unique token model where the staked ETH is turned into SETH2, and then the reward portions are actually turned into RETH2. So you need to hold SETH2 to receive RETH2, which represents the rewards. So these are like the representative tokenization decisions that liquid staking protocols are making today. Now, the node operator onboarding process is also very significantly different. I'll start off with Rocket Pool's example, where Rocket Pool, by design, how they've approached it is that the operator, anyone could be an operator as long as you have 16 ETH, as well as a small amount of RPL tokens. And the RPL tokens that you require are always going to be changing depending on the price of RPL to ETH. And as you can see, the others part here for Rocket Pool's node operator are like very small operators that I've aggregated together. It's not just one entity, so you can see like there's like a very diverse set of operators that are being onboarded to Rocket Pool. Now you could compare that with Lido's approach, where it's a governance-first approach. Lido is taking its time to vet and also analyze which are the operators to bring on, and then you could see that therefore you're not going to see like a ton of hundreds of operators. You're going to see a few set, and this is roughly the distribution of the keys that are being operated on Rocket Pool and Lido. I know someone had a question in the earlier session about Lido, whether or not like the key distribution is transparent. You could see it right here. These are data points pulled a couple of days ago. Yeah, so these are the two design choices. So hopefully this shines a light on what liquid staking protocols, like the critical sort of design choices that have been made up to date. And hopefully the liquid staking protocols to come also keep these in mind and consider whether or not any of these fit better with the model that they're trying to create. And now this is where we get to the juicy part. Because in my opinion, so the design decisions are just one part of the entire story. Liquid staking, by design, what it means is that you are able to transfer the locked staked tokens. What that means is you want to do something with it. If it's not doing anything, really, then you could use operators like stake.fish. You could use operators like an exchange because you don't need to do anything with it. But the moment you have a tokenized version of staked ETH, it means that you want to do something out in the DeFi market, out in the market of whatever is available today. So unfortunately today, I think outside of Lido, we haven't seen a lot of adoption just yet. So which is why I'm trying to use Lido as a proxy to showcase what the market participants are thinking, what they want to do with the tokenized versions of ETH. So in the case of Lido, you could see that the vast majority of people are locking it into Curve. I'll get into like what that means later on down the road. But you could also see that a lot of the staked ETH tokens are being used for lending protocols like Aave, Anchor, as well as MakerDAO. So the key point here is that there aren't a lot of people that are just holding, that are just like holding the staked ETH and not doing anything. So hopefully this does provide evidence to my point earlier that if you have a tokenized ETH, most likely you want to do something with it. Let's look into Curve from the get-go then, because this is one of the first use cases that Lido brought on, and I'll walk you guys through on like what's going on. So for Curve pools, for those of you who are unaware, is where you could deposit tokens that are supposed to trade, equal to each other. A good example of this is like the Curve DAI USDC USDT pool are very famous. You could take any of those stable coins and trade with very minimal slippage. And also the interesting about Curve is people who do provide their liquidity on Curve are do get the Curve token reward incentives as a reward. So what Lido did was essentially created a pool for ETH to staked ETH. And they've incentivized this heavily with the Lido's governance tokens, LDO tokens. And of course, Curve also provided their own incentive, their own CRV tokens as well. And so this pool really blew up. Like a lot of people liked it, so they deposited ETH and staked ETH. And I'll show you guys how much it grew over the past couple of past year. But it's been a massively very popular pool. And one interesting thing to note is that it is the single largest pool, DEX pool out in the market, period. Even none of the stable coin pools even match up to the ETH to staked ETH pool currently today. Now, I did add like a slightly derivation at the end because with the Curve pool token, so once you deposit ETH and stake ETH to Curve, you get an LP token, which then you could then take to other DeFi protocols to do more interesting stuff. You could take it to Convex, to Wi-Fi, you could take it to Element, which will help you basically rip out the interest, the staking reward rate into like a senior and a junior rate. There's like all sorts of interesting DeFi derivatives that have been using this Curve pool. Now, you might be wondering like why Lido did this in the first place. Well, the reason is primarily because of how important Lido viewed the ETH to staked ETH token, peg is going to be. That peg is very critical because liquid stake. We all talk about liquid staking, but at the end of the day, what liquid staking means is that if you have a tokenized version of the staked ETH, you could trade to ETH very easily with low slippage. Most of the liquid staking protocols are not really focusing on this, which is extremely problematic. This peg is very important because this is the only way you get whales interested. If a whale is staking $20 million worth of ETH and they tokenize it and they realize they can't trade it back to $20 million worth of ETH, they're not going to simply use that liquid staking protocol. They need to have the liquidity depth in order for them to feel comfortable to use that liquid staking protocol. So as an example, I've taken the three, like Rocket Pool, Lido, and as well as Stakewise, the biggest DEX pools that they are managing currently actively. And you could see Lido has like $4.8 billion worth of liquidity currently on the Curve pool. And this is based on staked ETH to ETH. And you could see the effect of it here, right here. So this is like a very recent snapshot of how much you could trade for staked ETH to ETH. Right now, you could trade $900 million worth of staked ETH to ETH with less than 1% slippage. That is insane. That is good enough to make any whale comfortable to actually own staked ETH because they know they're going to get very low slippage on trading back to ETH. Stakewise, interestingly, I am giving an honorary sort of like shout out, primarily because despite the low liquidity, they've really taken advantage of the V3, Uniswap V3. On Uniswap V3, for those of you who are unaware, you're able to concentrate liquidity on like a certain price ticks. And what Stakewise did was really concentrate all of their TVL on like a single price tick, which is why you could see that despite having only $166 million worth of liquidity, you could trade the Stakewise tokenized token for ETH with like less than 1%, about 1% slippage. You could trade about like $80 million worth of, oh shoot. you could trade about $80 million worth of Stakewise's tokenized ETH token for ETH with 1% slippage. And to show you that this isn't just like specific to just like DEX or DeFi, the stake.ETH peg has been amazingly competitive even against centralized exchanges. Centralized exchanges, surprisingly, they also have their own tokenized versions of the stake.ETH on their platforms, but they don't let transfers out. So you could still have, like, for example, Binance has something called BEF. BEF is what you get when you stake ETH on Binance, and you could trade that. They have an active market to trade that to ETH. But as you can see on the chart I have on the right here, there's various price points of like slippages that you could see on Binance, Huobi, and Bitfinex and Kraken, where a lot of these pegs did drop to like even less than 0.8, 0.9. You could see even Huobi, like the staked ETH to, the tokenized version of ETH to ETH traded even at like a 0.7 ratio. Compare that to Lido, where at minimum it dropped to only 0.95. And again, that is an impressive amount of liquidity as well as defense of the peg. Now, why does this peg matter? Brings me to my next slide. So you need oracles in order to have lending protocols, because the crux of the lending protocols is that they need a liquidation price. If any of the loans are under collateralized, they need to be able to liquidate that in order to make sure that the integrity of the lending protocol is intact. Now, how do you get that oracle? You need to maintain a market. Hence why this price point becomes very, very important. On Lido, given that the oracle price of stake.ETH has never dropped below 0.95 and has such a deep liquidity pool of like 4.8 billion, of course, obviously, Chainlink is going to be comfortable creating a price feed for it. Obviously, lending protocols are going to take those historic price points as well as the liquidity pool as indications that most likely, even in the harshest of market conditions, they have a price oracle that they could rely on. So thanks to that pool and that peg and that oracle, you're able to then see initial lending protocols come online, like Anchor, which is a lending protocol on Terra. You also see MakerDAO adopting it. Oh, the chart below, the two charts below represents the amount of stake.ETH that are going into Maker currently. And it really brings me to like the really the most interesting, I think, concept out there, because up to now, all the initial lending protocols I've pointed out here are mostly all depositing stake.ETH and borrowing DAI. And as someone who borrows DAI or like UST on that lending protocol, you need to make sure of collateralization ratios. What I mean is, if at all stake.ETH drops below a certain price point, of course, MakerDAO or Anchor is going to liquidate you. You definitely don't want that. But on Aave, the interesting thing is you could deposit stake.ETH, but now what you can borrow is actual ETH. So what we've been seeing in a lot of the market today is a lot of people, what they do is they bring their stake.ETH, they deposit it to Aave, they then borrow ETH out, they then convert that, stake that into stake.ETH, deposit that again to Aave, and you keep doing that a few times, and what you end up with is a leveraged reward rate on your initial stake.ETH. And I've put together some figures here. The stake.ETH reward rate currently is like about 3.96%. With only 6 iterations, you reach a 12% reward rate. So you've effectively tripled the reward rate from your initial stack. And the stability of this is, and one thing I could say is this is a pretty stable strategy too when it comes to using your stake.ETH. The reason why I say that is because I've calculated that unless the stake.ETH to ETH ratio does not fall below 6.7%, you're fine. You will never be liquidated. And historically, what have I pointed out? I've pointed out that Lido, the price peg has not fallen below 0.95. So which is why this entire usage of Aave and leverage staking is a very interesting one. And so hopefully that gives you like a good taste of like how Lido went from maintaining a curve pool, how it created with price discovery, how it provided defense on peg, and then you end up with like really interesting primitives like leverage staking, which arguably has interesting risk profiles compared to other lending strategies out there. Hopefully that helped paint a picture about the use cases. I wanted to briefly go into like the future of liquid staking. I really do think there's a lot of opportunities out there. Like the growth for it is going to be immense. And just to prove my point, Ethereum has one of the lowest staking ratios. Staking ratio is how much Ethereum is staked over how much Ethereum is actually circulating. And of like the top networks, you could see Ethereum is currently at like only 9% staking ratio. Compare that with any of the proof of stake networks out there, take your pick. These are all in the mid to high digit, staking ratios. So currently, you can see on the top there, that's the current market today. Assume even Ethereum reaches the medium staking ratio up here, you see liquid staking is going to blow up to be like an $83 billion worth of market. And even assuming Ethereum reaches a staking ratio that is close or near, no pun intended, but nears staking ratio, you reach with a $53 billion market for liquid staking. So the future growth is limitless. I do think we will have multiple players in this space. It is possible to have multiple players in this space. I think, I really hope no one is sleeping on the wheel on the opportunities and the growth expectation on liquid staking. And here's some other short-term expectations. As I mentioned, the market, I really strongly believe is going to grow, easily double, triple in the next year. That increasing staking ratio is going to lift all boats. I don't think it's only going to be Lido that's going to be enjoying this run-up. There's definitely going to be other liquid staking protocols as well that will definitely see a lot of growth. And as well, we'll see new entrants because they're going to look at the same thing I'm presenting you today and thinking, wow, there's a big opportunity. We should enter into this space. But I really want to emphasize and warn that there's a lot of things that needs to be put in thought. You need to think about operator onboarding. You need to think about liquidity, peg incentivization, as I presented to you about to really reach the Lido state of use cases. And yeah, use case bootstrapping also is something important to keep in mind as well. Unless a liquid staking protocol is keeping all these things in mind, I do not foresee them to be competitive in the medium future. Really hoping, to any new liquid staking protocols out there that are trying to build up, I think a lot of the operators are really open to providing advice as well as discussing about any points. So please do reach out to node operators or even the existing liquid staking protocols because they're going to be able to provide you with advice, guidance, as well as a few things that they could have done better. Because at the end of the day, it's a cooperative environment. Ethereum is all about making sure that we create the most resilient, decentralized system out there. So please do not be disheartened. Reach out to folks who have been doing this for a very long time. And I do want to point out that liquid staking, decentralization is really a hot topic. Of those of you who are on crypto Twitter, you would have seen things happening yesterday. So I don't want to put a blind eye to that. There's a lot of discussions happening on it, as rightfully so. But what I hope is that the community constantly thinks about these stuff and really bounces debates rather than trying to think unilaterally one way is right or wrong. Because unless they're this is a great venue to actually continue those discussions. What I really don't want to end up with is a mob mentality where we're only promoting, where we're only going on to the one side of, of the decentralization spectrum. So just wanted to emphasize that, let's talk, let's keep talking about this. I really love the conversations that are happening, but let's just constantly talk, keep an open mind and not make decisions on what is the right way of approaching decentralization. Post-merge transaction fees and MEV distribution, I don't even need to talk about that. Rocket Pool and both Lido are both this is a very high priority item for both of these teams. We'll see more conversations. They already have initial specs specs on their forums about how they're planning to approach it, but there's going to be a lot more discussions happening throughout the couple of days from now, and I'm expecting a lot more conversations to lead up to actual developments of how this would look in the next couple of months, definitely. If I had a minute, I was just going to show this bonus round, client diversity around like each of the liquid staking protocols today. To be honest, like Rocket Pool is like killing it right now in terms of like making sure that they're not running Prism. Lido, of course, could be better, but still, it's better than the overall network, which is very indicative of the efforts of trying to make sure that client diversity is a high priority item on Lido's minds. I mean, Izzy spoke to this point earlier as well. I did want to give a shout out to like rated.network, and Dune. Like these are very powerful analytic tools that will help you, bring up similar insights and similar sort of data points that I have presented to you today. I'm pretty excited to see how liquid staking protocol evolves. Let me know if you have any questions. You could reach out to me on Twitter at proofofjk. I'm open to discussions at any point. That's it. Thank you. And should I take questions first? Yes. Oh, okay. Yeah. If there are any questions, happy to take any. Oh, yeah.
Right over there. All right. Can you back up first? All right. There we go.
Thanks. Great presentation. When you talk about new entrants into liquid staking, do you see that it's a bit of a race to the bottom in terms of fees being charged by the different liquid staking providers to the end users, like Lido and Stakewise, obviously at 10% right now?
Yeah, so as a validator, like we've seen how it evolves on other proof of stake networks, the fees are always a race to the bottom. But there's a certain point where it stagnates. And I do think on Ethereum as well, we'll see at a certain point it will stagnate. Like there's no reason for, people will just like not care about like 1% or 2% more of discounts. So there's going to be a point to stagnate. I don't think it's going to be the main contention of whether a liquid staking protocol gets more adopted. I think it's more going to be more focused on the use cases. Like as an example, the leverage staking part is really what drove Lido's huge run up of recent. So I'm more focused on the use cases, at least for now.
Okay, so in regard to client diversity or lack of client diversity, how would a major slashing event on Lido, for example, would affect,
Yeah, so the thing about slashing is that if it happens, that operator is gone. Like, what I mean by that is, basically imagine, I don't know if you do use multiple chains, but imagine there was a new chain called Rainbow Chain. And the Rainbow Chain literally had a hack and, like they had like a serious hack and all the applications just went down. Funds were being siphoned off or whatever. Imagine the worst case scenario. Would you ever use Rainbow Network ever again? Like, probably not at all. That's the level of seriousness that operators take slashing. The moment it happens, we're done. Like, we need to pack up shop and like our reputations are forever tarnished. That's the reason why all of the operators, they've had zero slashing, because that's our worst case nightmare. Like, so what I'm trying to get at is that what happens if a slashing happens is such a nightmarish scenario that I don't think would happen. It's like almost akin to me asking what happens if Rainbow Network gets, hacked. No protocols would want like, yeah. Oh, so.
But I was asking regarding resilience. Yeah, okay. It's a maybe it will never happen or it's a low chance. But regarding the resilience of the system, because you are using staked and you are reporting it in the protocols, and then you get a liquidity token and you use it in another place, and then isn't that a domino possibility?
It's definitely possible, but again, my argument is almost close to like that of a client bug. Like, what happens if a client has found there was a big bug in like Prism or Lighthouse or any of the big clients today? Like, that causes a domino effect, right? Like, you see DeFi just like all being done, basically. So yeah, I don't like. I get your point, but at the same time, like that's the level of risk I see at it. You know, if it happens, it's Armageddon, right? Just similar to like any client bugs.
Yeah, and if I can add color to that, so that's where you see a lot of focus on client diversity, because we don't want a supermajority client, which would cause such an event in the case of a client bug, right? And we just don't never ever want to find out. And the other focus is on DVT, distributed validator technology. That's really interesting. I think that's the next big thing for these big staking providers. So you don't have the problem of I hold the keys, I can get people slashed. That entire problem goes away with DVT. All right. What else do we have for questions? Don't be shy. Back there. Okay.
Try out leverage staking, definitely. It's pretty fun.
Hi, good talk. I think the liquid staking token is a fairly inflexible product. What do you think could be future use cases for liquid staking?
I think leverage staking is really what is one of the more like interesting primitives that have come out in a while. Really, like any of the USDC or like USDT borrowing and lending, like these are mostly either farming governance tokens, which is again unsustainable yield, whereas like we're talking about staking reward rates, which is rewards coming from actually securing the chain. Like a while back, way back, like I think 2 years or back, the way I like to think of like the potential of staked ETH or like the tokenized version of liquid staking in the DeFi ecosystem is that it is productive collateral. Collateral locked up does nothing. Other than like providing the buffer for you to lend or do any other DeFi stuff, but lock in a tokenized version of liquid staking, that is productive. That is being actively contributing to the security of Ethereum, and that is super fascinating. And so I think we'll see a lot of these cases where DeFi protocols will adopt the token liquid staking as collateral and think about how they could use the reward rates to direct that to new users, bootstrap new users. There's obviously, of course, you could do like interesting stuff on like NFTs. Avado is an example of like them wrapping a interest yielding token with NFTs. I'm quite sure something similar will come out on staked ETH. I think we haven't seen the ends of it. I'm not a DeFi know-it-all, so can't tell you like what is next on the horizon. But we'll see a lot of these like interesting iterations. Element is also one thing that I think we'll see a lot more iterations of. The reward rate being taken out and separated from the collateral itself is also an interesting primitive. So curious to see what happens on that front too.
All right, anybody else? Going once, going twice? All right, well, thank you, JK.
Thank you, guys.
We'll have our next talk at 2, so there's a short break here.
Okay, thank you for coming back. And we will have Kirill here from Gnosis Chain, not XDAI anymore. It's Gnosis Chain. Talk to us about Towards the Beaconverse. Please join me in welcoming him.
All right. Hello, everyone. My name is Kirill Fedoseev. I'm a developer and researcher at Gnosis Chain team. So today we're going to talk about our vision of the future Beaconverse. So the plan for today is I will start by talking about the current status of the Gnosis Chain, how well it performs, and so essentially what it is today. Then we'll share our general vision on the future of the Beacon Chain, and as we call it, the Beaconverse. Then we'll share our amazing experience behind the launch of the Gnosis Beacon Chain product, which our team is very excited of. So we'll talk about when, how, and why we launched that. Of course, I will also outline all of the available options, how you as a staker can easily participate in validating the chain. And we'll also share some roadmap on our future products that are coming to the Gnosis Beacon Chain infrastructure. So just that's the things we are currently working on. So Gnosis Chain. Let's just look at some numbers. Gnosis Chain was previously known as XDAI. It was one of the earliest production-ready sidechains. It was launched back in 2018. So its unique feature was that the native currency XDAI was directly pegged to DAI stablecoin, which provides a very convenient option for users to pay for their transactions in stablecoins, and it appeared to be very cheap for them, so you can easily fit hundreds of transactions for as little as the cost of a single US dollar. So Gnosis Chain today is 100% EVM compatible with the mainnet, and when I say this, I mean the full compatibility including EAP 5059. We also have cool 5 seconds, constant 5 seconds block with fast finality. The chain is being natively supported by the Nethermind and Open Ethereum clients, and currently it is driven by the delegated proof of stake consensus over a 30-round consensus with 19 active validators. And so from these numbers, everything seems very great, but some time ago we started to considering why don't we try to switch the Gnosis Chain consensus model to the Ethereum proof of stake actually. And when we start thinking about that, so why everyone should start considering at least switching their own sidechains to Ethereum proof of stake or create new sidechains which is based on top of Ethereum proof of stake consensus. And so here's the list of points we came up with. So by switching your consensus to the Ethereum proof of stake in a sidechain, you definitely achieve the tighter Ethereum compatibility. You drastically increase the number of validator sets which are participating in your chain security. You get much higher community involvement, and the combination of lower validator entry requirements and the ability of reusing existing Ethereum staking infrastructure will definitely allow you to achieve much higher value securing the chain, which is also a good thing to have. And finally, as a killer feature, in the multi-beacon chain verse, the trustless bridges finally become possible. So I will also touch this point later on. So what's about our vision of this beaconverse world? Basically, we believe that the future of Ethereum ecosystem in general is going in the multi-beacon chain dimension. So why do we think that? We have seen the similar transition happening with the fast and rapid adoption of the EVM environments in the past years due to EVM success and popularity. And while the proof of work consensus was really hard to adopt in the sidechains, we think that proof of stake Ethereum consensus is much more suitable for the sidechain adoption. So eventually we will see much more sidechains to be created on top of Ethereum proof of stake, and more beacon chains will be eventually launched, and the wider adoption of Ethereum proof of stake will come in the sidechains world as well. So that's how the term Gnosis Beacon Chain appeared. We decided to make a step forward and be the first one who will launch essentially the first alternative beacon chain. And in short, we launched the Gnosis Beacon Chain successfully on the December 8th of the last year. Since then, we have been actively working on the growth of the active validator set, participation in the consensus security. Now we are actively planning and working on performing the merge with the Gnosis chain later this year. And after that, we will start working on the upcoming hard forks, similar to the ones that are planned in the mainnet. So this includes withdrawals, dunk sharding, and so much more. And just it was a nice opportunity for us to find a way of giving back to the Ethereum ecosystem, as just we don't want only to pull something from the Ethereum, but we want to give back. And so why do we think that launching of our beacon chain is so much excited? Yeah, you probably know that there are a lot of beacon chain testnets, and it's not that hard to launch the new testnet. New testnets are being launched every day. But so why Gnosis beacon chain should be different from that? So we believe that testnets are just the toy copies of the mainnet in terms that they are only used for testing a specific client feature or an interoperability between different clients and tools, while the Gnosis beacon chain aims to be much closer to the mainnet environment in terms that it has real value back in it. And at the same time, it still allows some additional room for further experiments. So when I talk about this room for experiments, I essentially mean changing tweaking the spec parameters. So that's the spec parameters which we tweaked in our chain. First, we reduced the slot time from 12 to 5 seconds, so that after the merge, the Gnosis chain will keep this constant fast blocks of 5 seconds, and it won't be changed. We also make a small step towards this idealistic concept of single slot finality, and try to reduce the epoch slots from 32 to 16, and combined these changes allowed us to achieve a much faster target finalization time of just as little as 2.7 minutes. We also drastically decreased the required deposit amount from the validator, so everyone today was already talking that 32 ETH for a single validator is probably too much. So we just decreased it to just as little as 1 GNO token, which in today's market is somewhere around $350 US. So that's it. And now let's talk about the way how we went to the launch of the Gnosis beacon chain, what we did essentially to successfully launch it so that other side chains might use our experience for their adoption as well. So it all started with the consideration of the changes required to be made in the deposit contract. So the first significant change was, of course, the fact that deposit contract supports on top of ERC20 tokens. So we do not deposit native ETH or XDAI, we deposit ERC20 GNO inside of our deposit contract. We also decided to add to not deposit GNO token directly, but instead to introduce the wrapped token flexibility and add essentially the hidden wrapped token with a fixed conversion rate of 1 GNO to 32 meta GNO tokens. So we did this for two main reasons. First, just to have some additional flexibility and control for the future logic of the deposit and possible withdrawals. So we don't want to stick to the just native GNO token. We want to have some additional just flexibility around that. And it also allowed us to use the same scale mathematics behind the effective balances of validators. So in mainnet, all numbers are based around the value of 32 staked ETH. So we don't want really to make any confusion here. So just to put the 32 MGNO tokens in the deposits and we are good. We also added the inside support of the batch deposits, which is nicely integrated in now the simple deposit UI and allows users to create hundreds of validators in single transaction. And as we probably want to put some withdrawals logic later on, once the withdrawals will be enabled, we probably would like to unlock some GNO tokens. So we eventually deployed the deposit contract behind a proxy pattern, which will allow us to upgrade the implementation later on. So the next thing we considered was, of course, the most interesting part is always about rewards. So the way we did this is we took the rough estimation of the target maximum annual inflation of the GNO supply, and we considered that we are okay with the 4% annual inflation, and by targeting this number we calculated just how much we can tweak the base reward factor, and eventually we ended up with the following rewards. So right now you can easily earn somewhere around 18% APR on your validator, and with the realistic target of 300,000 validators, the APR will be somewhere around 10%. And of course, this is just the APR coming from consensus rewards. After the merge, the validators will also earn some small percentage on the priority fees as well. So the next big thing was, of course, about the adaptation of the consensus clients. So when we initially tried to just get some understanding if it is possible to run the Gnosis beacon chain with the change spec on the existing clients, we didn't find a way of supporting it in the existing version of Lighthouse, Prism, and other clients at that time. So we ended up just performing the genesis on our own forked version of these clients. But exactly after the genesis, we started hard working on making clients to support GBC out of the box. And we also spent a lot of resources on bringing other minority clients on board to the Gnosis beacon chain. So after all that, the current progress is the following. We have a full native support of the Gnosis beacon chain in Lighthouse and Teku, although some people still complain that Teku is not fully supported yet, but at least our experience shows that it works perfectly fine. So this full native support means that you can essentially connect to the Gnosis beacon chain by just specifying the / network just equal Gnosis, and this will connect your client to the Gnosis beacon chain. We still have some troubles with the Prism client because of the compatibility problem on the execution layer RPC, but hopefully this will be resolved soon as well. And on Nimbus side, we have a quite convenient build time native support, so you cannot use the official binaries or Docker images, but you can just prepare a specific binary during the build time to configure it to be able to run with the Gnosis beacon chain environment. So during our testing of the consensus layer clients within the Gnosis beacon chain requirements, we also uncovered some challenges that appear for the consensus layer clients to handle. So basically, we noticed that the Gnosis beacon chain significantly increases the requirements for the network connection and its utilization. We also noted that for effective node operation, Gnosis beacon chain, its nodes need much higher peer count requirements. And we also find it difficult to monitor the lots of running validators, so there is no appropriate way currently of monitoring hundreds of validators that you may run on the Gnosis beacon chain on a single node. And as a fight for the client diversity, one of our goals was also to create some uniform and very simple to use client configurations and launch scripts. So essentially we came up with the set of GitHub repositories with the Docker Compose configs, and now it is as simple for end user to launch any client they want just by executing a couple of commands. You essentially clone the all necessary configs and just then Docker Compose up and you're ready to go. All right, so on the monitoring side, which we considered next, so the first big thing we adapted was of course, open source block explorer. So we took the beacon char amazing block explorer and converted it to fit our needs. So just tweaked some pages on it and launched an amazing block explorer for our Gnosis beacon chain. Then we also just adapted some client diversity dashboards and the peer-to-peer crawlers so that you can get a rough estimation on how the network performs in terms of different clients, how many nodes do we have, how the client distribution works among them, and so on. And as we also have some quite positive experience in our different projects within the data analytics dashboards. We also added this on top, so that's just a very nice tool you can use to monitor the number of made deposits, the number of unique withdrawal addresses, and so on. And yet still we struggle to find the suitable monitoring and alerting solution for advanced stakers who stake more than like a couple of GNO tokens. So that's the thing we are planning to address in the nearest future. All right, so the next big thing we really did with the Gnosis Beacon Chain launch was the creation of the different grant programs. So we have two big grant programs. One was just the seed incentive program for early adopters. This basically meant that we distributed the pre-funded GBC deposits to the early adopters, validators, in exchange for the completed KYC process. And we receive a very great feedback from the users, and most of the nodes that were pre-funded by this way are still being operated by today. So users they didn't turn them off. They're still participating in the consensus. They're earning their rewards, and they will be finally rewarded by the introduction of the withdrawals in the end. And we also had a very successful partnership with the DAppNode and the Avado node providers for onboarding more home staking validators. Just the way it worked, that the users who bought the new node from these providers, from their official shops, their nodes already came with the pre-filled number of validators, and so the users were happy. They put in their node at the home and start staking. So just everyone was participating in these grant programs. We're really excited about it. Then our recent update on the Gnosis Beacon Chain was the addition of the liquid staking. So we heard a lot of talks today about that as well. So we have completed our partnership with the Stakewise, which we're really excited about. So what this essentially added to the Gnosis Beacon Chain is the additional tokenomics around liquid staking with SGNO and RGNO liquid tokens with daily rewards. So this also included, of course, the curve pool for SGNO-GNO stable pair. And we think that eventually it will allow for more DeFi products to be built on top of these tokenomics in the future. So we have seen today a lot of talks about the usage of liquid staking tokens in the different lending platforms, in liquidity provider pools, and so on. So we believe that SGNO tokenomics will also catch up with that infrastructure in the future. So, and just look at some numbers about the Gnosis Beacon Chain today. So we already passed 4.5 months since the launch. We now have 82,000 active validators, or even more. These validators come in from at least 600 unique deposit addresses, and the total amount of value secured in the chain already reached somewhere around $30 million US. So we also have a very top performing validators, and the average participation is about 98%. The current APR in the chain is around 18%, and this all comes as just at a small cost of 40 gigabytes of the total archive database in the consensus layer clients, which is not that much. And the only painful point we have here is the enormous Beacon Block Explorer database, which is approaching the 2 terabytes limit, but it's not something the users should worry about. That's completely on our side, so it's probably not that bad. So just to recap, how you can stake on the Gnosis Beacon Chain if you would like to participate in our great products. So you can stake at home in your own hardware if you have any spare computer hanging around, or if you're using something for Ethereum mainnet validation. You can also buy or use existing DAppNode or Avado nodes and try to maybe participate in the upcoming grant programs if we will announce new ones. You can also stake easily on any private server in the cloud, or in case you don't want to spend some time on launching the node by yourself, you can participate in the liquid staking through the Stakewise partner. And as a happy bonus, we do not yet have any custodial staking from any centralized exchanges, which I guess everyone hates, so that's kind of a good thing. that we don't have any, and I guess no plans for raiding that. So let's now talk about our future roadmap for the development of the Gnosis beacon chain in the recent future, in the upcoming future. So the first big thing is definitely the merge, and the optimistic plan consists of performing the merge of the Gnosis chain execution layer with the consensus layer a week ahead of the Ethereum merge, which is an exciting opportunity to test the transition before it happens in the Ethereum mainnet and just try to identify any possible issues if there are any. So technically, the transition will be soft linked to the particular block number through the constant difficulty. So in current consensus model of the Gnosis chain, the difficulty of each block is constant. So it's pretty easy to predict the particular block number the merge would happen if we just define the particular difficulty. So the Aura block structure will be deprecated eventually in the time of the merge. So the currently block structure is a little bit different in the Gnosis chain, and in order to be more aligned with the Ethereum ecosystem, after the merge we will have the canonical Ethereum block structure, so that it will finally allow easier integrations of the future products, easier addition of other clients, and further on. And from the client perspective, the merge will be performed with the flagship Nethermind client on the execution layer side, and it will be combined with any client of your choice in the consensus layer side, so that's just a good thing for the client diversity there. But as the client diversity for the execution layer always matters as well, so after the merge we plan to start bringing additional clients on board. So the first client to be supported by the Gnosis beacon chain will probably be Aragon, and as there is no any support for legacy block structures of the Gnosis chain in Aragon currently, it won't be able to catch up with the chain history from the early Genesis block, but we can try to create a proprietary state snapshot and essentially perform some kind of regenesis inside the Aragon. So it will start not from scratch, but from the first block of the merge, and this will allow it to not care about the previous history of the Gnosis chain at all. So the Ethereum proof of stake also brings a lot of benefits for the end users, but of course running the two clients instead of just one always comes at some cost, and it's not zero. So we expect that everyone should consider that switching to Ethereum proof of stake is not free. So we have some major parties involved in our Gnosis chain operation, so which are consensus validators, SBC service providers, and just advanced users who are running their own private nodes of the Gnosis chain. And we expect that all of these parties should be aware of the increased disk, CPU, network consumption, and just some additional complexity which this transition will bring to the Gnosis chain. So that's just something that should be considered for everyone, for anyone who is planning the switch to the Ethereum proof of stake. So the next exciting thing we are working on is the withdrawals. And so while the current mainnet spec is not finalized, but its latest update proposes the push approach for performing the withdrawals of the validators, so which is done by some system level Ethereum means, which is similar to how the current rewards distributed to miners. So this approach is not directly applicable for our ERC20 deposit contract use case, but we plan to use a hybrid approach instead. So it's better to see it on the picture. So the first, at some point when the beacon chain withdrawal happens, the system records it during the block process into some system contract, which might be the block reward contract we are already using for distributing the bridge tokens. And then this withdrawal is getting recorded in the state of the block reward contract, for example. And after that, just at any time in the further blocks, the user operating this validator can pull the withdrawn token from the deposit contract, which will transitively check that the withdrawal is valid from the system contract, and finally perform just a regular ERC20 transfers and unlock the user's staked funds. So finally, trustless bridges. So trustless bridge is an exciting concept, and so for it to happen, we essentially need 3 building blocks. So the first building block is that we should believe in our own vision that the future of Ethereum beacon chains is in the multi-beacon chain dimension. So trustless bridge just doesn't make any sense if there is only one beacon chain. So we also need to have an Alteri specification to be implemented and available on all of the supported beacon chains, which is currently the case. So it is supported in the mainnet and in the Gnosis beacon chain. So that's just the specification that adds the native support for the light clients through the sync committees. And the only remaining building blocks of the trustless bridge is the EAP 2537, which is essentially about the adding of the BLS precompiles to the AVM layer. And after it is implemented, the beacon chain light clients can be now directly implemented in the smart contracts way, in Solidity, for example. And after that, we can combine any number of beacon chains inside this concept of trustless bridge. So essentially, just create a symmetric environment where you have smart contracts on the opposite side of the beacon chain, which are syncing in the light client way the opposite beacon chain, and now they just provide this simple interface of accessing the latest block hash of the opposite beacon chain inside the EVM layer, and just on top of that, you can easily build any information breach just by providing sufficient Merkle proofs, and that's it. So that's just a really exciting concept we are already working about, and hopefully it will be implemented as soon as possible. I guess that's it I have for you today. Thanks for having me here.
Do we have questions? Over there.
What do you see as the most compelling use case for Gnosis?
So just the most compelling use case, I believe, is just to find the perfect fit for the chain to be able to contribute back to the Ethereum ecosystem, so that we not just build a chain to just build a chain, but to also find a way of how we can improve the overall ecosystem of Ethereum world as well. And so that's one point. And the second point is, of course, just to make our Gnosis chain as secure as possible. So we believe that this transition might become better for the security of the chain as its current consensus, so why we are doing all of that. So we just want the more secure side chains, the more used side chains, the greater TVL in these side chains, so that's just the reasons.
Thank you for the presentation. I was wondering regarding like the requirements to like run a node like at home. Are they similar to the ETH2 ones?
So the main difference from the requirements mainly comes from the slots are faster. This definitely comes at some cost, and as you probably won't run just one or two validators, you'll maybe run tens or hundreds of them. So this all mainly increases the network consumption. So the main requirement increase is in the high broadband internet connection, but overall, I think the requirements are within reasonable bounds from the Ethereum mainnet ones. So we are using the same DAppNodes everyone uses for the mainnet, so there's nothing different from them. So I guess the environments are pretty much the same.
So how will the trustless bridge handle the forks? Will it be that every time Ethereum forks, Gnosis chain also forks, or there is another mechanism to handle forking?
Sorry, I didn't get it. Can you please repeat?
So, if you run a light client on the Gnosis chain of Ethereum, you know, like, and if Ethereum forks, you need to update your light client. And to update your light client, you need to have a mechanism to update this light client. So this mechanism, how do you make it sure that this mechanism is trustless? Maybe one way is that you always mirror. Maybe Gnosis beacon chain is always the same as Ethereum beacon chain. And in this case, well, that's easy. But now if you have some difference in the forking, you will need a way to update your light client. And how do you have a trustless way to do that?
So first of all, there might be some forks that won't require any updates to the light client. So it might be the case that there will be some non-major hard forks which will not require any changes, which is an optimistic scenario. Yeah, and if there are some incompatibility hard forks, then I see two possibilities here. So we either still introduce some DAO controlling the upgrade procedures of the light clients on both chains so that we have some decentralized in the best way possible just to upgrade the contract implementation. Or if it's not fine for you, maybe we can always just deploy a new fresh implementation of the light client and then tell all other projects just, okay, see, this bridge won't work anymore. You can just use the new version, so just update your own DApps to support the newer contract address. So that would be more trust-independent approach, I guess, but from the DApps perspective, it won't be very convenient, so that's just yet to be decided.
So my take on this is when we're saying trustless bridge, right, it's the question of where you put your trust. So I might get the tech wrong, but I think what this says is I'm running these light clients, say, in my phone, right? I can use that to bridge, but I still have to trust the client developers, and I have to trust the developers of the smart contracts. And that's the same with any chain today. You trust the client developers unless you audit the code yourself. It is auditable, but most people will not do that, right? And the same for smart contracts. It is auditable. Most people won't do that. You want to comment on that?
Yeah, I want to comment. So for me, trustless bridge is when you don't have relayers, you don't have validators, you don't have oracles. So you have only users and smart contracts, and users are bridging state between two chains themselves, right? There are some rules. Contracts on both sides can be upgradable, can be not, right? So that's a decision to make. But that's the main point, right? So we don't have relayers, validators, oracles between two networks to run the bridge. So if you want to move an asset, you do it yourself as a user, and there is no one who is helping you. But sometimes you need to move results of sync committees activities, right? So you pay more for gas, right? That can be subsidized, but if it's not subsidized, users will pay themselves, but they don't need to trust anyone in between chains. So that's my take.
Okay, you got a question?
For the casual home staker on the Gnosis chain, is there any way to get some reporting when you start missing attestations? Because last time I checked, that feature was not present in the Beacon Chain Explorer. Is that already part of it, or is that on your roadmap?
Can you repeat it once again?
Yes, on the Ethereum main chain, on the Beacon Chain website, I can set alerts for if I start missing attestations, for example. Is there any such service already on the Gnosis?
Not yet. So that's the kind of pain point, because it's problematic to find the right way of monitoring hundreds of validators. So just in case you are running hundreds of validators on a single node, and this node goes down for 1 hour, depending on electricity cutoff, you don't want probably to receive hundreds of emails. You just probably want to receive just one, but saying that all validators are missing out. So we didn't find such tool. You can suggest if you know anything, but the one from Beacon Chain Explorer I guess, was not suitable for this use case. And in the end, if we won't find any third-party solution for that, we'll just develop it by ourselves.
Yeah, I want to give some alpha. So there are two main Beacon Chain Explorer, Beaconcha, and another one. So another one is coming pretty soon. So it very likely will be an alerting system within, so you can set it up. So it should be around June.
All right. Other questions? Nobody? Okay. Well, then I have one question. When merge, before or after mainnet?
So in the recent news, so the current plan for the Ethereum mainnet, I guess that merge will happen in the Q3.
Sure,
and
maybe.
So we still have plenty of time.
Will you merge before or after mainnet? Before? Just before? Yeah, thank you. A week before. Yeah, that's just before.
Yeah, that's the plan.
Yeah, yeah, perfect. All right, thank you. right, thank you. This is going to be the last talk in this room today. We're going to have Elias from rated.network, and he's going to tell us about validator, rating and what's the word I'm looking for? I'm not thinking of? Reputation, thank you. For staking providers, this is huge, right? How am I? Am I doing well? Can other people see that? So please join me in welcoming Elias.
Thank you, everybody. So I'm going to be talking to you about reputation for machines, and particularly the case for Ethereum validators. I'm going to try and keep these relatively light. I know it's later in the day. The sun is shining as well, so we'll try and keep it light and brief, and then move into Q&A if you guys have those questions. Who is this? This is me. A little bit about me. I spent a couple years with the Coinbase Cloud team, and before that the Bison Trails team, working as a protocol specialist there, looking at everything that kind of touches the infrastructure layer of the industry and our operations there. And recently I left that role and co-founded Rated. And what Rated looks into, and kind of like the problem statement that we're thinking most intently about, is reputation for machines, right? This is actually like a pretty packed term, and reputation is something that you attach to humans, right? With agency, and then, you know, in a game that's played over multiple rounds, builds that reputation. But what does it mean for a machine to have reputation, right? Like a machine, like a validator in Ethereum's case, is something that is programmed, and there's a fairly deterministic input-output relationship. So where does reputation come in? And where we think reputation comes in is in the machine's sort of role as a medium of agency of the machine's operator, right? The operator makes certain design decisions, the operator follows through with an upgrade schedule or doesn't follow through with an upgrade schedule. There's like all sorts of bells and whistles and components of performance and risk, and basically how a node and a collection of nodes and thereby an operator entity, what is their standing in the network? How much positive externality do they produce in a network versus how much negative externality do they produce in a network? And, you know, right now the beacon chain might be like a relatively, it's not simple, but it's orders of magnitude more simple than it will be post-merge, right? And the agency that these operators will have. So when we talk about externalities, negative and positive, imagine that validators will effectively become arbiters of MEV. So validators will have the opportunity to do multi-block reorgs. They will have the opportunity to do sandwich attacks, or they will have the opportunity to do none of these things, right? A validator that engages in that type of activity is a negative externality, more likely a negative externality for the network, but maybe a validator that does only backrunning, and that's the type of MEV that they engage in. There's an argument to be made there about them being a positive externality in the network by improving the profile of the liquidity layer up top, and thereby kind of a better user experience at the application layer makes the benefits the security layer as well. And there's a feedback loop we see there. But there is a problem, and that problem is that all of this stuff that I was just talking to you about is highly subjective, right? It's not unboundedly subjective. There is like an imaginary bound of objectivity, but within that there's a lot of differing opinions, right? And so this kind of work stream and all the things that we're working on has been a thing that I've been thinking about and working on since about November 2020, when my colleague Sid Shaker and myself, we did the Medalla data hackathon. And one of the things that we got really interested in that process was, okay, what does performance mean for validators? What is validator effectiveness and so on? And as I kind of kept scratching on that problem, I realized that you ask two different operators, any two different operators in the network about what performance is and what risk is and what kind of this aggregated reputation is, and you get two different answers, right? And to us, that sort of feels like that old proverb, or maybe it's not that old, but who cares anyway, that, someone is seeing, like, people are seeing different parts of the animal, the elephant in that case, but there is actually a whole elephant, right? So the fact that brings us back to that kind of like relatively well-defined bound of objectivity within which subjectivity can exist, but there has to be a whole animal and not like a taken apart animal, right? Like there must be a more objective answer as to what performance and risk is than just everybody's differing opinions, right? So standards, in our view, actually do matter. But the way we think these standards can be the most sort of impactful for the community, and that's everybody, that's you guys, that's like everybody that's running nodes, that is thinking about research on the beacon chain and so on. The way they become impactful is when they sort of collectively express some sort of social consensus around what these concepts actually mean and how do we define them. And the issue there is that also the beacon chain and Ethereum is not static. It evolves. So, today it's a consensus chain that just exchanges consensus messages and is playing that game. Tomorrow there will be an execution layer on top of it as well. And then thereafter there will be sharding, there will be L2s and so on. So the information space really grows and the game itself changes over time. And so these standards can be fixed only for a certain period of time, right? So there's kind of like all kinds of upgrades that you need to do into those kind of views of the world, really, on what performance means and what risk means and what this aggregated reputation idea means over time, right? Now, you can be following, and we are, this is where our journey is starting. You can start with principles, right? Like principles like generalizability and specificity and all these good things that basically allow this view of the world to remain relevant and not sensitive to changes in the underlying rules, even if those underlying rule changes happen, right? So that there is no disruption into the view that is being expressed. Now, I'm sitting here and I'm talking to you about views of the world and subjectivity. Why does that actually matter, right? And well, before I get on to why that matters, I have an excerpt here from Jim McDonald, who was super kind enough to come by our Discord and talk about this subjectivity issue. And within that discussion, there was like this one excerpt that really stuck with me. And Jim goes something like, the issue is what this rating is meant to represent, right? And what does it represent? Is it how well a validator does absolutely? Is it how well a validator does considering the rest of the network? Is it the impact a validator has on progressing the chain? And then if you've been paying attention to the talk so far, you'll see that like there's all the more categories that you can extend this to, right? negative externality, positive externality, what's the frame of reference? They're all slightly different, right? And they can all be valuable, but it's a very rich subjectivity space that we can, I think, all benefit if we actually manage to organize this subjectivity, right? Largely, and that's not only an Ethereum beacon chain issue, it's actually across all networks. Data about the base layer of most chains is actually like not that very well contextualized at the moment, right? And we kind of think of it as that data can be really powerful, and we'll get to why we think that is in just a minute. But we think of that sort of data space and subjectivity space like common knowledge that there is like natural gas, huge natural gas resources in the Arctic Ocean, but it's hard to get, right? So what we're basically kind of applying ourselves to is building the icebreaker and then traveling into the center of the Arctic Ocean and then actually drilling for that natural gas, right? It's a shitty kind of analogy because natural gas is bad for the planet, but it's the one I have, so we'll stick with it. So now onto why this subjectivity idea we think matters a lot, why that data matters a lot, why consensus around things like performance and risk matter a lot. And that is that validators, specifically on the Ethereum beacon chain, are capital assets, right? You can almost think of them as real estate, network real estate. You own like 1% of the network if you have, I don't know, 3,000 validators or something like that. And by the mechanics of the activation queue and the exit queue and so on, there is actually like finite land, if you will, that is available on the beacon chain, right? So if you kind of like start thinking along the lines of that analogy and extending it a little bit more, where you get to is, well, so I have some land and I have a house on top of that land and I have a mortgage and I own that, right? And maybe I rent it out and I earn some future income that is actually quite predictable. The very similar terms as with validators. So basically, while like I can take my house, that asset that produces future cash flows and has a monetary value spot in the market, and I can remortgage it or get liquidity off the back of my asset in order to be able to fund new projects, to buy another house, to do whatever, like just access more economic optionality, we think that you can and should and probably most definitely will be able to do that, all that stuff in the future with your validators, right? This is extremely valuable network real estate. And so in order to build all these kinds of applications, to give validators and their operators more economic optionality, you need to get that data first. And you need to have everybody as much aligned as possible on what the interpretation of these things is, right? There is no authority that will say this is the way, but the way we'll unlock the most value is if we all somehow agree and we also have a platform in order to agree and upgrade our views of the world into what that framing actually looks like, right? And this is what we hope to offer to the community through our work with Rated. So it is a journey from elevating capital validators as capital assets into exploring their financial asset potential, right? And so right now you can check our website on rated.network. We contextualize basically things, information around performance and risk around validators. We also have an API that we haven't been very public about, but it's been awesome to see members of the community actually like find their way into that API and start building things on top of that, and then get in touch and kind of offering feedback about what they would like to see and what would enable them the best. And so let's talk a little bit about like some of the use cases that we see for that type of data. And this is only kind of like a limited view of the future, right? Like we practically approach things. I don't know. Did any of you played Age of Empires ever? Can we have a show of hands? Cool. All right. Well, a lot of people. So like in Age of Empires, you started like in that settlement, and then there was like the map was all black around, right? Like this is how we see the present, and all the map is like the future and the directions in which we could actually develop this, and like the different types of products we could elect to enable, or not elect to enable, but like actually enable, and maybe build ourselves, and so on. But it is very much like that. You explore the map a little bit longer, a little bit more, you stumble upon some resource, and then you re-inform your decision function about what am I building next? Am I building the armory, or am I building the granary, or am I building the horse stable, whatever. So right now, we have found some pretty interesting use cases for our data. So Nexus Mutual is actually working on a slashing and downtime and penalties insurance product that they'll be going to market with pretty soon, together with their V2 release. So we're working with them to help power pricing for that slashing insurance, and be a source of truth for events on the Beacon chain. We're also working with Lido to help them kind of understand better about new operator onboarding, what performance means, and then maybe down the line there's even a pay for performance incentive scheme that we could help power within Lido, or like within any staking pool that our data can be valuable at. Some other use cases that we've seen and we've had discussions about are powering that with that sort of subjective view of the world, and with that view of the reputation of an operator, powering distributed validator technology, right? Like feeding that system information about who they let in their threshold signature enclaves and so on. And then as you start kind of like exploring that Age of Empires map and weeding out the complexity and ordering things, you can imagine things like financial derivatives. You can imagine things like, maybe not in Ethereum, because that's not the way things work, but maybe in other network smart delegation algorithms. You can think about uncollateralized credit, a ton of use cases, but they all require that fat data layer in the middle. So this is kind of how we see the world. Just to give you like a little bit of an idea of the work that we've done so far. So if you again go to rated.network, you'll see something like this on your screen right now. So we're basically contextualizing in building upwards from kind of all the different elements of validator performance and the available historical data on chain, and then aggregating into things like participation rate, inclusion delay, and correctness, and then combining all of these metrics into a one effectiveness metric, which we might keep calling effectiveness rating, or we might call it something else. But the crux of it is that there is subjectivity upon which we think we can be the most valuable if we actually download input from you all, and not come from like a high seat of authority and say this is what effectiveness means, right? And it is only in that way that like not only the data itself, but the products that they power can have the biggest impact to everybody that's running validators and is operating in that network. And if you kind of abstract things a little bit further out, and you look at the 10,000-foot view of the world, like what is proof of stake, right? It's an algorithm that takes as input value at risk and operational excellence, and then as an output, it provides security. So if we're able to actually contextualize that data appropriately, we directly impact the operational excellence idea, because now everybody knows where they stand in the context of the network, right? And it's an incentive for everybody to rise to the top. But at the same time, we're also influencing positively the value at risk side of things. Because if we're able to power all of these products and increase economic optionality for validators and their operators, we effectively create pipelines for more value to find its way into the security layer of the network. And it's only when we have a really valuable security layer of the network that we can build the most powerful and important applications on top of that, right? So we'd love to hear from you. We'd love for you to get involved in that conversation. We'd love for any of you that are building at the hackathon tomorrow to play around with our API and come by the Discord and ask us questions about how to do that. If you want to, do read the documentation and our approach. Do give all of your feedback. I would love to hear from you about, how we should view this world. And we're very excited to be exploring what we think is a pretty rich data space that is largely still underexplored. So as I said before, you can find us under rated.network or in the Bird app under @ratedw3b. Thank you very much. Do we have questions?
All right. Do we have questions?
Thanks. So I'm Rajesh from LaunchNodes. Hi. Great presentation. Thank you.
Appreciate it.
Are there plans to make the data available as an oracle at all, so that you can incorporate it into chains and contracts?
Something we're thinking about very much.
Okay.
100%. We haven't scoped it out yet. So we're in the process of building out the team, and we are hiring for someone that can basically kind of like take over all of that bundle of work and own it. But to answer your question, very much so, yes.
Okay. Perfect. Thank you.
Who else? Over there.
Thank you. So I saw on the website right now currently you have the layout. You've basically shown the effectiveness per operator. But I'm curious, have you taken a look at different cuts of how the effectiveness differ by clients or geography? I saw there may be ways of doing that. I'm quite sure you could do that. But I was curious, if you've already taken a look at what you see on preliminary results.
It's a great question, and there's a few pieces to unpack there. So one is where we get the data from, right? Because in order to be able to look at geographies and so on, which would actually be super interesting, we need to get high quality data from the P2P layer of the network, which is another big, like the Oracle idea, this is another big scope of work for us that we're actually trying to find someone to join our team that can basically completely own this. So yes, and this is something that we're very much interested in. As far as kind of comparing maybe I can show you actually, because this is an interesting one. As far as comparing clients go, there's a lot of things that kind of intermediate the performance, right? So I'm also a little bit scared to do that because I remember getting a lot of flack for doing it from Ben Eddington back when we did the when we did the Medalla data challenge. Bless him, he was right to call it out. So it is. I will defer to people smarter than me as far as client performance goes. Jim McDonald had like an excellent presentation just earlier, so if you guys didn't catch it before, definitely kind of revisit on the recording he had. And his conclusion was that, well, clients are better at different things, and so it is a benefit to the network if they all exist and they all work together, because it's like playing like a basketball team, right? But to answer your question and give you like a little bit of an insight into maybe what the client performance head-to-head looks like, we basically in looking at labeling the different entities and so on, there's like various open source work that's been done in that respect. We actually stumbled upon the 4 client teams because so we're running Blockprint, which is an open source tool designed and published by Michael Sproul from Lighthouse, and basically Blockprint does runs a process called fingerprinting, and it looks at kind of the trace that block proposers leave on the network, and then classifies the client according to that data. And so we had found like 4 entities that had 144 validators each, and then once we run Blockprint, we basically stumbled upon the fact that each one of them is running specifically one client. And then we're like, well, these are the client teams, right? So just for OPSEC and good measure, I'm not going to confirm or deny if they actually did confirm or denied. But there's a pretty strong indication that that's the case. So as you can see here, Lighthouse is actually, we released this feature recently. It's in the top 1% of the whole network performance. So I think they are the top performer as far as network effectiveness goes. They all operate pretty tightly to one another. The interesting bit here is that it actually looks like the Prism client team is performing the worst of all the 4 teams on the head-to-head, but still it's a pretty stellar performance. And the other thing that you'll see is that there's actually not a whole lot of variation in kind of how the effectiveness rating is shaped across entities, and there's really 2 things there. One is that even small variations, 0.5%, 1%, and so on, as the numbers increase in US dollar terms, they can actually make a huge difference in rewards and penalties and so on. So that's part number 1. Part number 2, again drawing from Jim McDonald's talk earlier, as there's more validators on the Beacon chain, as there's more messages, as Beacon nodes are getting increasingly busier, and especially when you bring the execution layer on top, we think that you're going to start to see that variation actually spread out quite a bit. And then until everybody gets used to this new reality, there's going to be a period of turbulence. It's always been like that in every network out there. Like Kusama, for example, last year was onboarding parachains. They had a very turbulent, I want to say 3 months, right, with like a crazy cadence of upgrades and downgrades and so on. So this is all to be expected. Yeah, we're pretty excited for all of it, as it were.
Do we have other questions? Going once, twice? No? All right. Thank you.
Appreciate it. Thank you.
We'll have Danny Ryan in the main room at 4, and I think we're done in here for today.